All right, welcome everybody. I'm Fouad Zeineddine. Thank you for being here. This is the first hybrid workshop of the Methods in Social Change and Inertia series, part 2 of From Words to Waves, Methodological Approaches for Analyzing Social Change Dynamics in Ecological Text Data. I'm organizing this with the support of the University of Greenwich Institute for Life Force Development, Center for Inequality, and with funding from the British Academy Talent Development Award in support of a project I'm doing on social change in the Middle East and Southeast Asia. I won't be talking about my project today, but I plan on telling you all about it once the series is at an end in February next year sometime. Before we begin, as usual for this series, we'll take a moment's silence to commemorate and be in solidarity with everybody who's continuing to suffer genocide and ecocide across the globe, and the challenges and crises that we're trying to address with this work. Thank you. So today's session is part 2 of a 2-part workshop. Today we're going to be talking Professor Simon Angus, professor at the Department of Economics and co-founder and co-director of SODA Labs and the Monash IP Observatory at Monash University, Australia. He's a computational and complexity scientist. And will be talking to us today about transformers and LLMs, and as well how to use these computational methods and integrate them in research design. Without further ado, I'll let Professor Simon go ahead. Thank you.
Thank you. Thanks, Fouad, and thanks again. I'll repeat my thanks for being able to be with you, and like you'll see in my background in a moment, I'll go over briefly again as I did yesterday. The prospect of social change and inertia, wide-scale social change and so on, thinking it as a complex system, thinking through methodological approaches to that, from agent-based modelling to natural language processing. It's kind of my world. And you'll see over today, this morning, and our session this afternoon, when we think about designing a research approach to these things, it's very much part of what I'm interested in working on. And particularly, my work increasingly seems to have more of a human rights interest and focus, and particularly at the Monash IP Observatory. So yeah, it's a real privilege and honour to be able to join with you guys here and discuss the project, but also hopefully help with some thoughts on tools and techniques that might assist with the project itself. This is the second of 3 workshops, I guess. I'll show you in a moment where we are in the series by way of kind of orientation. I'll again just briefly say who I am. So as Fouad said, I work across computational and complexity science, AI, NLP, etc. My background is in more complex systems thinking and agent-based modelling. That's probably, yeah, there we go. And I teach in big data and AI with students at Monash University, Australia. And at SODA Labs, which we founded a few years ago now, we build things. So not only do we build platforms like the Monash IP Observatory, which I'll talk more about this afternoon as a possible exemplar or way of thinking about social change tracking and measuring at large. It may be something to consider. But we also build other tools like Assistant AI, which is a new tool that's being deployed across Monash to help our researchers get access to AI tooling independent and agnostic of platforms. So we think researchers should be able to try out and probe models of a variety of flavors from different model providers. That's really the job of academics, I think, to be able to characterize, probe, understand these new forms of intelligence as they are being rapidly adopted. And it's actually quite hard to do that for universities because they're like an enterprise like anyone else, and they're often encouraged or coerced into a single platform enterprise agreement. And whilst that might work for a business, in an academic environment, that's really challenging. And so we've tried to build a tool which is completely agnostic to models, enables you to sequence models from different providers or ensemble them and so on. And that's what Assistant is, which we hope to open source in the next couple of months. And another one I'll just mention briefly is the flavour this morning is more about AI tooling, is Astro, which is available to all of Monash as well, which is a way of doing natural language search over our entire research database. So we have 75,000 papers so far that we've vectorized, which we'll come to today, using transformer models. And then users can, rather than having to find keywords to find research capability and so on, they can just write a natural language query or copy and paste one from a grant proposal or request or a philanthropic kind of aims, a government call, or even just to find another researcher related to an abstract that you're writing on. You can put it into Astro and we'll vectorize that, find the papers that are closest to it, cluster them, display them, and provide reports. So that's the kind of things we do at SOTA, and it has seen, I guess, a non-traditional form of research in some ways for the last few years for me, doing both research stuff as papers, etc., but building and maintaining now tools that are used by other people. Briefly on SOTA Labs, we're, I guess, a quirky organisation which works at the intersection of machine learning, AI, and so on, and quantitative social science with a causal inference background. We were established a few years ago, myself and 3 other colleagues, and yeah, we're really up for work that tries to make a bit of a dent in the universe. And at that intersection, we built the lab because we realised that just bringing on board and then training kind of bilingual researchers who are capable in their domain, but also in computational science, is not easy. It takes time, and often then they leave. A lab gives us a bit of a platform to hold on to some of those people, and particularly our platforms that we work with. So we've managed to convince our business school that more of a physical sciences lab actually makes sense, and it's been replicated since. There's now 6 what are called impact labs in the business school, and SOTA was the founding one. So it seems to be working, and for something that is about research translation and so on. Okay, so where are we today? We're in session 2. So yesterday was an on-ramp to the first, what I'm going to call waves of natural language processing that might help us, which was to do with bag of words and word embeddings. My theme yesterday, if you were here, were looking online, was really to say, don't forget that there's some powerful tools that are simpler but are still transparent and usable in that first couple of waves. And I tried to demonstrate a range of research, not from ancient history, but some published even in the last few years, using these tools. And for a variety of reasons, they're still a worthwhile and adequate place to go. However, that said, since 2017 and the development of the transformer at Google, we have a new way of handling human text and solving the text as data problem, which I'll come to in a moment. And this morning is going to be all about what does that new kind of revolution or wave bring us. My theme today, however, is not going to be so much that, hey, you can chat GPT everything. It's going to be actually that there's a range, there's sort of an ecosystem of tools that is now provided, backed by the core architecture of the transformer, which are really useful for doing computational approaches to human language. So I'm going to try and show you a range of different applications of transformers to the research workflow and why and how they work and why they might be useful to you. So I guess my one-line theme today is it's not only about ChatGPT. I actually probably won't mention it from now on. This afternoon, we kind of abstract a little bit more and we talk about designing or thinking more practically about how to actually embrace a larger research paradigm or project, which is what's going on here. And I'll give some more, I guess, conceptual thinking about how I think about it and approach it for what it's worth from my experiences. And hopefully that will start some good conversations. And again, after this session and this afternoon, I'll point to this GitHub repo that I built called TextWaves, which basically applies all of these things in as minimal as possible Python environment that I could kind of come up with to give a whole bunch of examples and a pipeline that you can then adapt and use, hopefully to benefit, or just as a learning tool with synthetic kind of data set creation and then working with that synthetic data in a variety of ways. But we'll talk about that maybe later this morning. Okay, so briefly again, we're solving or trying to come up with solutions to this core problem of text as data, which is that we've got a whole lot of potentially useful, valuable, unstructured data, which is not currently in a form that most of our econometric or statistical models work with, which is usually tabular, organized, or structured data. And when you think about it, actually, the world is full of unstructured data, and it's actually tiny is the amount of data that sits in structured form. And up until fairly recently, we've only really, as quantitative social scientists, been able to work with the structured form. What has just been changing in the last 5 to 10 years is sort of a set of keys that is starting to unlock this remarkable amount of information and now can be turned into data through these text as data tooling. And so whether that's through what traditionally was humans having to do this, which was very laborious and costly, really was this sort of like drinking through, I guess, a straw from all of this available information. Whereas now, with some of these computational techniques, we've got the ability to widen up the pipe and really get a lot of information very quickly into structured forms. Again, I'm not going to suggest we're quite at the world of Tony Stark where, you know, we maybe ask Jarvis to pull up different data sets and analyze them on the flow, but to be honest, it's not, doesn't feel that far away. And in the lab with Assistant, we embed voice activation. And as I was describing yesterday, you can have moments where you feel like, oh, this must be kind of like an Iron Man thing, where you can have hands off the computer and talk to models and they respond in native kind of text, in voice, and you can interrupt it and you can keep having a conversation. As I said yesterday, sometimes it's weird. You leave the room and there's no one else there, but you feel like you just ended a conversation and you're kind of like, who else was in the room? My kids, you know, hear me talking to someone and like, who have you got? I'm like, sorry, that was a model. But that's the world we're about to get into. So maybe the future of our workspaces will be talking to models rather than writing to them. Okay, so let me talk about then, I guess, how to think about this just briefly again from a conceptual standpoint. And that's something I'm going to emphasize this afternoon is whenever you think about text as data, sometimes you can get very obsessed with the technology, but I want to suggest that we need to start with a good theoretical and conceptual basis. So as an example, I work a bit on questions about democratic resilience. And yeah, there's a paper that I hope will get accepted soon, looking for the email any day now, that is basically me giving a view of how you could articulate modern transform-based tooling and other tools towards the question of tracking democratic resilience. And you can imagine reading from left to right, wherever your kind of area is, you'll probably start with a set of research questions. And it's really important you start here rather than starting with the tooling. You'll then think about kind of the ways, for example, here, the research questions are around, say, populism. And it may be narratives around populism, so the way we speak about that, the kind of stories we tell each other. Typical narrative analysis typically starts with focus groups or surveys, or maybe some text as data methods. And then moving on to more computationally heavy methods, we have these tooling over here. And as I described, yesterday's conversations was more about this traditional NLP part. Today is going to be about the transformer NLP part. But I just want to situate the fact that I'm going to talk a lot about sort of techniques and technology with some applications. But I just want to remember and remind you that it always needs to sit within a framework of like, what is the theoretical or conceptual basis? What's the hypothesis we're testing? Because as I explained, ultimately the reviewer and our world won't probably be as impressed as you are with your cool NLP technique. What they should be impressed with is the really interesting research question you've been able to ask, perhaps for the first time because of unlocking new data, or that you've been able to push the field forward by showing some fact that wasn't previously known because of the cool data. It's not about the cool data and then what do we do with it. Although I will make a comment about big data this afternoon, which may have a flavour of that, but I'll tell you why. Okay, so again, very briefly, yesterday we did bag of words, which is by way of background, we don't think about the sequence or the context of the words at all. And we just treat them as numbers and we're going to count them up into word frequencies, which is still useful, but obviously we lose a lot when we do that, versus the first or the second revolution, which was word embeddings, where we've got individual words now located in semantic space. And actually this space is meaningful. So the location for words in this space actually surrounds other words that have similar meanings. And we talked about applications. Both of these via, for example, TF-IDF, so term frequency, inverse document frequency vectors here, and versus word embedding average vectors here, can take text as a sort of input and produce a computer readable, mathematically, feasible vector form of it, kind of a location in the world. I guess the big difference between left and right here is that the vectors here don't really have any kind of semantic relationship to anything. They're just our depiction of a dictionary and alphabet, if you like, and the numbers and the frequencies. Whereas this one, because it's training on millions of words, and the context of those words actually has some meaning in that space. So that's a really major step forward. And to be honest, when I started working with these early on in NLP, when they had come about, I thought this was just, revolutionary. And the fact that we could have vectors that now actually had some semantic content to them and could be added and subtracted, and they gave us meaningful changes to those vectors, seemed to me to be a huge step forward from where we were here. But I didn't know at the time the step that was coming. Okay, so let's talk about the transformer revolution. This is my attempt on one slide to give you a kind of under the hood, behind the scenes view of what's going on in the modern LLM, generative AI, transformer models. But I'm going to show it to you and make 4 really important points about it, because it's going to be the sort of fulcrum on which the rest of this morning sits. My claim that there's not just a ChatGPT out there. Okay, I said it one more time. There's lots of different models that can be like different techniques that fall out of this architecture. So briefly, the architecture starts at the left with a sequence of text. And this time, it's actually going to be read in as a sequence. All the words, we don't drop anything, don't change or stem anything. It's not a TF-IDF world. And we have all of that sequence, and it's going to be followed through these main transformer sections. We've got here, I'm showing you both what's going to be called an encoder and a decoder side. I'll come to a bit more about both of those sides in a moment. This is sort of like a full or complete model, and it's rare that you see all of these blocks, the encoder and the decoder side, in modern tooling today. Only really translation engines would probably do that. What comes out of the encoder, and this is the transformer area, is going to be a vector. And that's the high dimensional representation, now not averaged across words like in word embeddings, but actually representing the latent, the hidden semantic content of the sentence or the text that I've given to it. That sentence is like mind-blowing. Okay, so the vector is going to represent not just an average of words in isolation, but the actual underlying human idea that formed, if you like, when was driving that textual rendering of that idea, at least as close as we can possibly claim to be. And it's all going to be driven by this new technology, this multi-attention transformer block. But if I've only got a vector, you might think, oh, well, that's not very useful. No, vectors are really useful, right? A vector representation of text is what was our bread and butter for TF-IDF or word embeddings. We get a better vector coming out here. And so that's one of our first applications of the transformer block, is it's a better encoder. So it's a better way of encoding human sequential text. And those vectors are really useful and were the first wave of scientific applications of transformer models, which we'll talk about. However, if you want the text to then be rendered back into words and actually be guessing, for example, what the next text is and be doing completion, then you need a decoder. So you need to go from the deep kind of semantic space and you need to then convert it back to what the next output word would be. And that's where it's going to choose from its vocab. As I said before, most of the models we deal with that are generative these days actually don't have this full encoder architecture. They just have the decoder architecture and they're trained standalone decoders. Some of the models we're going to work with are only going to be ones that produce vectors, so they don't have the decoder, they just have the encoder. As I said before, only really the translation engines where you need really good attention and sequential kind of words in and words out at the same time will end up usually having both. It just takes a much longer time to train both of them. I'll show you in a moment a diagram which puts all of these on the same map. So 4 things I want to emphasize. I know that's like early in the morning and probably a little bit much to take on board, but there's 4 things that are important. The first is, as I keep emphasizing, for the first time, we have a sequential representation of human text. That is fantastic, like an amazing step forward for those of us interested in trying to capture human meaning in our rendered textual form. The transformer block, as I described, I'll say a bit more about in a moment. This is, if you like, out of the whole slide, if we were to lose everything in a fire, what would you run back into the library to keep? It would be the plans for the transformer block, because that's the bit that's really the core technology driving all of the modern generative AI and tooling that we have. And it's the thing that is able to do this really rich representation of the semantic content of words by looking at lots of different sequential things at the same time. We'll come back to it. Okay, autoregressive. So if you've got a generative model, so this decoder block, and you're starting to produce words, keep remembering that it's like an autoregressive, like AR1 process. Words are going to come out this end and they get joined back to your sequence, and the sequence is going back in again. And it's going around and around and around. Sometimes people maybe forget that every time a new word is produced, that's a full trip of the model for your sequence going through. That's important because it means that whatever words or tokens you've put in the starting part of your prompts, if you're using a generative model, every one of those will already be firing off transformers and their attention and starting to change the statistical window of the next words that are going to be suggested to you. So it's like most autoregressive processes, there's a shadow of history that always applies, right? There's a long way that whatever you said at the start is still having an impact many words later when it's generated. We know this, and you can try it yourself. In other presentations, I like to do what's called a fish injection experiment. So take whatever prompt you have, probably not to do with fish, and just put the word fish somewhere in there, like third or fourth word. The early models would get completely thrown and start talking about fish. I asked, for example, some facts about, the Apollo moon landing. And if you put the Apollo fish moon landing, then early models would confidently tell me about the fish experiments that were done on the moon during that landing. Complete hallucinations, but fascinating to see how easily I could divert them from sort of the somewhat realistic statistical kind of basin of attraction into this completely made up world where fish were on the moon. Okay, and finally, please remember that these are trained as probabilistic next word detectors or inference machines. They are not trained on truth. Hopefully for this audience, we live and breathe this problem when we're dealing with students with models and so on. Hallucination's a real thing. That's because their training task that they're given is come up with the most likely word that would come next that gives what's called the lowest perplexity, which is the lowest surprise. So something that is most lucid, most plausible to come next based on all your trained or viewed amount of information that you've seen from training. So we send millions and millions, in fact, billions of sequences of words through these models and tuning all of the transformer knobs until we're getting words coming out the end that make sense. It is amazing to think that that is such a simple task, choose the next word. And yet, for humans, perhaps it's the task, way of thinking. What were you thinking I'd say next? Maybe it's actually what we already are doing all the time when we're listening along. I mean, there's a sort of a crazy thought here, maybe to discuss at the cafe or the bar afterwards, that human cognition is nothing but next word prediction. It's fascinating, right? And a bit spooky. And from a self-organization and complex systems perspective, it's kind of delightful to start thinking, so all these emergent properties around so-called intelligence may actually be arising from what is a rather simple process of next word prediction. And yet we have this emergent capability of mathematical or analytical ability. It seems to understand now some sort of latent concepts about numbers and algebra and, hyperbolic functions. Nobody taught it that. It never went through those sort of, teaching lessons. But in a sense, it has read so much stuff that next word prediction has taught it some sort of emergent intelligence around those things. Maybe, or maybe it's just simply plausible. And that's the only thing that these models are ever going to be. So as an example of next word prediction, just to ground this, I started with Bob Hawke's, our former Prime Minister's election speech. By 1990, no Australian child will be living in poverty, he said. And if I put that in, he actually said, we will, and he said, achieve this goal by implementing a range of. Now, if I put that into the model and I ask for its probabilities, The word achieve could have been, so it's actually the highest likely outcome because it looks like the model was trained on the actual text, but it could have been work, which is 22% likely, strive 10%, do 6%, focus 4%. The sentence actually makes sense with any of them. We will work, we will strive, we will do, we will focus, right? But the highest probability, not massively highest, 38, 39 versus 22, is achieve. And so that is, if I was to set the so-called temperature of the model to be low, that means not to have a lot of bouncing around in the statistical likelihood, I would choose probably that top word every single time. And this would be achieve, and it would do it somewhat deterministically. If I set the so-called temperature higher, then there's a bit more energy, and I sample from further down this distribution with some likelihood. And that's all temperature is in generative tasks. It's effectively how wide a scope I should have with the potential top number of tokens that are predicted next. Okay, hopefully you're still with me. The 4 things I want you to remember about the architecture: sequential, transformers are important. It's definitely autoregressive. For all of that, context is going to matter. And all that the end of the day they're doing is predicting the next word. All right. Let me situate then, because my theme today is it isn't just one kind of AI or generative AI transformer. We've got a transformer that's behind a whole lot of different systems. So this is a really nice rendition, now a little bit dated for 2023, but it's a good way of showing you the sort of tree of life of transformer technology. And if you start down here, right, so these are the word embedding only. This is where we were in 2016. By 2017-18, we started getting the initial encoder-only technology. So many of you will have heard of BERT or variations of BERT, like RoBERTa or SBERT or DBERT, etc. This is all really useful for researchers, okay? And there are subsequent models that are encoder-only, for example, OpenAI's models, which one of which, the small embedding model, I've taken into our TextWaves repo. So these have continued to be used, and there's now a variety of encoder only. So words, sentences go in, paragraphs or text, and they produce a vector out. That is that sort of branch of the technology space. Then there's this encoder and decoder. So as I said before, this is really only really useful when you're trying to track for a coordinated reason between the inputs and the outputs. So translations is a key area like that. Bigger models to train, both you've got transformers in the encoder and decoder block. And some of you might be aware of these, like Google's T5 or UL2. And these are really useful when it comes to those specific subset of tasks. Then you've got the sort of generative AI part, and these are the decoder only, so the right-hand side only models. And this is where you can see GPT-3 is down here. So that's the first kind of pretty performant version of what now OpenAI has in its GPT-5 most recently. And you can see the absolute profusion of models that have come from here because people got really excited about the generative capabilities. And that is the bit that's sort of, Anthropic, Google, Meta are all got models that sit in here somewhere, and that's where we are. Just again to make a bit of a note here, in terms of open source versus closed source, the number of open source models, largely in Encoderland, is typically open source, right? So you can download and install various encoders on your machines and you can run them because they're usually not nearly as unwieldy. The closed source ones, you can see, is largely over here. Why? Because, well, it's where a lot of the value is. And there's a lot of platforms making merry out of decoder-only models. And I guess just as a comment, we were having a conversation yesterday, doing AI or generative AI research as a social scientist, it costs money, whether it's in computation with open source models or with paying platforms to get access to models. And it's non-trivial costs as the intelligence increases. So there's huge opportunity here, but there's also, we need to recognize not everyone will have access to the same models. And a viable and valid kind of, I think, part of our research activity is to keep examining and trying to think through how can we make more accessible techniques and technologies at cheaper or free entry points. Because presumably we can't all survive and we'll get less useful scientific progress if we've got very expensive closed models is the only thing that's really on the offer. Okay, Let me say just something quickly about the transformer blocks. For some of you, you might have seen this before, but this is, I think, quite a nice rendering from the Explaining Transformers GitHub. This is one way of kind of conceptualizing it. So thinking about the transformer attention. What I want to show you is that this is sort of activations for the level through the sequence of text here, colored by different heads of attention. So what that means is there's parts of the kind of the matrices, the neural architecture within these models, which has, as an emergent concept, as a learned property, come to focus on different aspects of human text. And they each sort of play a different role. So for example, here, this fourth head, you can see the activation is more towards the beginning and very much less towards the end. It seems that it's learned, this one's paying attention to the beginning of the sequence, right? It's sort of its specialization when it comes to understanding human text. We can go on to the next one. You can notice this one, its activation is throughout. And if you look at the things that are being activated, you can see it's basically the pronouns, right? He and him throughout. Again, no conductor, no orchestrator has said, you need to focus on the pronouns and you need to focus on the verbs. This is something that's an emergent reality from the training of just that simple task of next word prediction. Okay, we can look at another one. So this time it's looking at the commas, right? It's been trained to come up with that as its attention part. For the next one, you can see here, this is now the nouns and associative adjectives, and so on and so on and so on and so on. When the transformer heads have got, these are all operating at the same time, looking at their own, like, look, self-attention is the word. They're looking at themselves, at the text that's being produced and the text that is in the system. And it's sequentially understanding all of these things, if you like, superposed at once. It's like different layers in a figure. That is what's giving it, I think, this amazing ability to kind of really deeply or more deeply understand the latent or hidden meaning that actually sits behind the text. Remember, the text, like any language, is our rendering of something that's deeper, more cognitively kind of rich, which is what we were thinking or trying to convey at the time. It's very hard to get someone to see that. We don't have techniques for that. Language is our, you know, our current method of trying to get someone to see what we see when we're thinking. And you can see that this training has developed these multi-talented, specialized ability, all happening at once within the transform model to try to understand our language. Okay, so the transformer, I've claimed, can now power a whole lot of different techniques that are useful to us and potentially really helpful in this kind of project around social change and anyone working on text as data at scale. So I've listed, I think here, probably 5 key areas, but there could be more. So I've already mentioned that transformers can be better encoders. So this is transformer playing the job of giving me a vector, which I can drop in and replace for my TF-IDF or my word embedding vector. Transformers as translators, I've mentioned already. We can actually bring different languages to the same language through harmonization, or I'll show you an example this afternoon, where expanding and translating in one step, for example, tweets from a global audience can be really helpful for trying to understand a global movement where people are expressing things in different ways. Again, like, that's mind-bending, because previously I would have had to stand up a expert in 16 or 18 different languages who also has some understanding of the, you know, hashtag universe. But the model has seen everything in its training. And so it's got the ability to work seamlessly across all these languages and environments and give me a harmonized data set around that. We'll talk a little later about biases and so on, but like, it, at first approximation, is a very powerful tool. Transformers as labelers. So this is where we're actually asking a model to, in a generative sense, provide a label to some text that's coming in with some particular instruction. Transformers as detectors. So this is where we're not asking the model to generate a token, but actually we're going to use the statistical activations of the model to detect certain shifts in language. And we have a method called paired completion, which uses this. And then synthesizers. So in the TextWaves data set, I've got 2 options. One of them is a lexicon-based synthesizer for text. You can see it's really complicated and it's quite clunky, the text that comes out. versus the language model approach where I prompt it and say, hey, here's a job, come up with some tweets that look like this from this stance, and it's very easy for it to do that because it's trained on making lucid text. And in this case, hallucination is a feature, not a bug, all right? So that's, again, something really cool. It used to be that if you wanted to synthesize data in a controlled way, you would need to get an army of humans to write laboriously all of these things out. I mean, generally, we just don't ask anyone to do that. It's mind-numbing for a human to do that. They run out of creativity pretty quickly, whereas a model can build us a synthetic controlled data set really quickly to test our pipeline and to progress our science or demonstrate the validity of our approach. Okay, so there's 5 different sort of methodologies or pipelines that come out of the same transformer block. So what I want to show you is some examples of these, and that will be kind of the morning. Okay, so first on the encoder side, yesterday I introduced Elliot Ash's cool work on Relatio, which is this micro-narrative discovery. We took that in the lab and we updated it with transformers back in 2022. And what we're able to do is first use transformers more effectively. So this is a BERT-based role extraction where we're able to get the semantic roles played by different aspects of the text and the words to do that with a tool that's been trained using a BERT encoder. So that's one transfer. So we're trying to find, remember this micro-narratives part introduced yesterday is trying to find an entity, a verb, and an entity. And that's going to be the basis on which we can then quantify how many times that particular framing or micro-narrative has been shown in the text. So the first usage was to get better semantic role identification. The next was, remember, we faced a dimension reduction problem where if we've got lots of different ways of saying the same narrative, we want to reduce the complexity so that we can count up the more frequent things. So drop-in replacement, instead of using what Elliot did at the time, which is in his group, perfectly reasonable, using word embeddings, we use sentence embeddings, again, with a BERT encoder. So that's a transformer-backed encoder. And we're able to show that you get a more accurate and powerful outcome because we've dropped in the better technology, which is able to uncover and identify human latent meaning. I mean, we did a few other things, but again, using synthetic data, we were able to show that you could follow time sequences of micro-narratives more accurately using encoder-based approaches based on transformers. So that's helpful. And just to the side, once you've converted your texts into semantic space using a transformer-backed encoder, similar to the word embeddings, but even more so, that semantic space, that encoding space is sort of, it's a stable space that you can work with and bring other texts into it and follow texts over time. It's not moving about. It's been pre-trained and you're merely locating your texts in this space. So it's really cool. You can then take a whole bevy of texts, convert them using some sort of high dimensional encoder. So for example, the 3072 dimension OpenAI embedding large version, that's a really rich high dimensional space. You can then actually add to that over time. You can cluster in that space. You can look at how clusters are moving over time. You can bring that space to a lower dimensional setting like we do in TextWaves, where I bring it down to 2D using UMAP or PCA. And you've just got all this flexibility, all of the things that you would want in this high dimensional representation, and all the following kind of research methods are now available to you because you've got an accurate representation of where your texts sit in that space. You know, all of the ones that probably speak to a position on, you know, pluralist democracy versus, you know, autocracy, they're all going to kind of gather together in this semantic space. And that is really powerful. There's lots of things that you can do in this sort of world. So, you know, don't forget encoders. Most people, I think, rush to generative models, but the encoding part of transformers provides you with a very rich and very powerful and very flexible world in which you can run analyses of human text at scale. And frankly, it's really cheap compared to everything in the generative world. A lot of what I do, you know, with encoders, for example, at Astro, I'm still in the free tier, and that's a university scale research database. It's extraordinary how cheap encoder-based pipelines can be. So it's a great access point. If there's not a lot of resourcing, encoder-based transformers are a great option. Okay, so the one that probably most people have thought about, and this is probably the closest to like, could ChatGPT label my stuff, is to think about LLMs as labelers. But there's some considerations that I just want to briefly talk about. So this is where I'm going to, rather than have, I'm going to start with maybe humans doing some expert domain specific labeling. That's going to be useful for validation. We'll talk about that more this afternoon. And then I want to scale it up. So I want to be able to say, can I use a large language model to do the labeling and do it at scale? So take, for example, a current president of the US who said in their inauguration address in 2017, for too long, a small group in our nation's capital has reaped the rewards of government while the people have borne the cost. And I want to ask a model, does this exhibit a populist narrative? Okay, and I ask it to provide your answer from the set strong yes, weak yes, unsure, weak no, strong no, and a brief up to 10-word justification for your response. It's a really standard sort of social science labeling prompt. Notice that I've asked for a verbal textual answer rather than a number. Models are getting better at giving numbers, but I would still recommend using text-based answers and not saying out of a score of 0 to 100, where 100 is. The reason for that is that models don't see numbers like we see numbers. They're just tokens. They're just like, it's, as one colleague said to me once, don't look down, don't pick up a pen, but tell me how many strokes of your pen would it take, if you're writing out your name. And you're like, I don't know, like I would have to do a bunch of work to sort of estimate what that would be. It's because we don't really think about, like the atomic unit for us for human language is typically letters. As I say, how many letters are in your name? You're like, boom, well, 5 for me. But strokes of a pen, it's like, it's not how I think about language. Strokes of a pen is not the atomic way I think about language. In a similar sense, numbers and words are not the atomic way that these models have been trained. They've been trained in what's called a token, which often is a word, but not always a word. And particularly with numbers, it's typically not, 36 followed by 37. It's a 3 and it's a 6, a 3 and a 7. It has no idea that that's like an incremental number. That would be an emergent feature, right? So I would still recommend playing with outputting text, not numbers. The second thing is, notice I've asked for a justification. Yeah, early on it was thought that models were really pretty truthful when it came to explaining, why they came to some conclusion. Recently, work by Anthropic of others have shown that models aren't always true internally to the explanation they're giving. So take it with a grain of salt, but I at least prefer from a development standpoint to have some rendering from the model of why a particular choice was made. This is particularly helpful when it comes to trying to get a better prompting strategy to identify a particular label. It's good to see at least what the model says it was doing. So you go, oh, I realise now, I understand this was the logic it applied based on my prompt. And I think it still satisfies me a bit more if I have a whole bunch of labels produced by models and there's at least an explanation there rather than a fully black box environment. I think it's good for us as researchers to at least have something to hang our hat on and say, well, the model thought this when it was doing it. However, that, as common as the way it may be, is dangerous. It's what's called a zero-shot approach. The reason why it's dangerous is that notice I haven't given it a definition of populist narrative. And that means that this prompt alone throws my definition, like throws the entire kind of meaning making of populism onto whatever the model's training information is. It's asking it basically from its world knowledge, trained from all the texts it's ever read, what is a populist narrative? That is not very safe grounds, and scientifically, you're kind of opening yourself up to all sorts of model biases and mistake making. So I'm going to show you in a moment a comparison between zero shot, which is I'm going to call this, versus an extended prompt. In this case, I'm going to say, does the text exhibit a populist narrative for the same task? But the model is going to have to respond yes, only if it fulfills a 5-dimensional definition of populism, which is taken from Majors and Zavlov in 2021. So it's got to exhibit a Manichean worldview. Politics is a moral struggle between good and bad. 2, indivisible people, the ordinary people to be indivisible. They are seen as homogeneous. 3, general will. 4, people centrism. 5, anti-elitism. And notice I said it is considered populist if it fulfills all 5 dimensions. So the bar has been raised significantly for a positive ascent if the model can follow the instructions. And I get the same answer as before. This is an extended prompt, and I feel like it's much safer territory because whose definition of populism? My definition. What's the actual requirement? All 5. Not 3 from 5, not 2 from 5, but all 5. That's going to be important when we come to look at the results. Okay, and I'm going to do this as an experiment against 3 of the main model houses, Anthropic, OpenAI, and Google, and a variety of their model strengths. So this is the experiment that I set up as part of the paper I mentioned before. So there's going to be 90 prompt responses here. The way I've done it is the left-hand panel is going to be zero shot, and the right-hand panel is the extended prompt. So we're going to be able to compare those 2 panels. And I've got 9 balls here for representing Anthropic's 3 models. So moving from the left, which at the time was the best model, so Claude Sonnet 3.7 on high reasoning, through to Claude 3.5. I could have used Haiku, but I went for that. OpenAI goes from O3, so one of the reasoning models on high, down to GPT-4o. Google goes from Gemini 2.5 Flash on high, down to Gemini 2.0 Flash. So the model strength within these families goes from left to right in terms of strongest to weakest. And across here, I've got 5 different quotes. And loosely speaking, the top is sort of hopefully most populist. So that's the current president of the US for too long, a small group, etc. This is the VB party, which we looked at yesterday in one of the papers that I mentioned with bag of words approaches. So this is one of their claims from their membership magazine in 2008. We do not want to be part of the establishment. The VB is no protest party, but a principled program party. A maverick in Flemish politics. We are not welcome in the Belgian salons precisely because we want to abolish these salons. Good. That's a translation, by the way, by Claude from the Flemish, because I'm going to do all this in English so the translation is not a bias in the models. Then I've got the left front from France to end the social insecurity generated by the reign of profit so that adopted laws aims to satisfy the general interest rather than the insatiable greed of a few, and so on. The final 2, the first is my current Prime Minister in Australia, Anthony Albanese. His campaign launched in 2022. This is an interesting one because notice the text. Australians understand we can't bet our future on 3 more years of a Prime Minister, so this is him in opposition, who looks at every challenge facing our country and says, that's not my job. Literally, that's a quote from the former Prime Minister. For a decade now, the Liberals and Nationals have treated governing as an inconvenience and public money as a political slush fund. Now, it's got a few overtones of like populism in the sense that, you know, it's kind of like the elites are taking the money and doing stuff with them for themselves against us, the little people. But it really shouldn't be called populism, not in the sense of, fulfilling anything like the 5 claims before. And Obama, his inauguration speech, this is going to be my gold standard for democracy. There could be others, but each time we gather to inaugurate a president, we bear witness to the enduring strength of our constitution. We affirm the promise of our democracy. We hold these truths to be self-evident and so on. It's basically a rendering of the founding kind of beliefs of the democracy in the US. So what I should expect my prize is that in terms of does it exhibit a strong populist narrative, I'm expecting to see more kind of red for strong yes across the top here somehow, and more of a strong no across the bottom here in green. But there might be some variation within the model families, and there might be some variation between the 0 shot and the extended prompt. Okay, there's the answers. By and large, our prior is true. Obama gets a pretty ringing endorsement. This is not very populist, okay, across the model families. Albanese, as expected, notice on the 0 shot approach, he is populist. But on the extended prompt, he really fails to hit the 5 criteria, and so he's getting some results saying you're not a populist in many of them. Notice that it's largely to the left-hand side, okay, of these, which is the stronger models, which is about that following the instructions point. Notice that the left front, doesn't matter who you're seen as populist. Partly this could be length. It's a little bit longer, and so there's a more opportunity perhaps for hitting the extended prompt 5 questions. And for those reasons, notice that these 2, there's getting a little bit of disagreement, okay, but over here we're very populist. If I just focus in on what the models are talking about, I want to mention something about model strength. When you do implement labeling with encoders, with transformers, and you give that extended prompt, which I think is best practice and good to do, you've got to remember that the stronger models will follow your instructions more carefully than the weaker models. So if you said you need to hit all 5 of these things, it will probably say, well, no, 4 out of 5, it's a no, because that's what you said. Weaker models will be like, yeah, absolutely, looks like it, okay, and give you the kind of assent. So don't be surprised if when the model comes back, for example, okay, look at these kind of explanations. Claude says this is weakly, yes, that is weakly populist because it only demonstrates anti-elitism missing other required populist dimensions. So it's basically saying, yeah, look, this VB quote has got elements of populism, but it's not the full 5, and I know you asked for the full 5, so I'm going to say it's somewhat populist, but not fully so. So that's why it's sort of a weak yes. Here we've got a strong no, only anti-elitist language, no unified people or general will. So O3 has really slammed it and said, there's no way this could be considered populist because you asked for the 5 out of 5 definition. There's not even a hint of it, right? Because it's very clear about that. And similarly, Google, strong no, lacks explicit indivisible people, general will, and people centrism. So it said 3 out of the 5 don't match. It's definitely not populist. So even though these look perhaps like mistakes, they're actually just like following what you asked it to do. And so you need to be a little careful when you're constructing these extended quotes. I would suggest you probably want a 2-tier, kind of does it, when you explain populism, to what extent is it populist versus the more higher bar, I need all 5. And then you can compare and contrast between those two, for example, in these prompting. So labeling is definitely...
Yeah, so it looks like if we go back to the previous slide, if that's okay, the models just seem to have a different interpretation of what it means to have all 5, right? Like
Correct.
For some of them, have all 5 just before I even consider a yes. Whereas others, like if there's a few of them.
Yes, that's right.
So would you imagine that they would agree better if we were also more explicit about is it an and or an or?
Yeah, absolutely. Yeah, and so that would be in my, if I was to do, like I did this experiment
Just as a demo,
as a teaching tool within the paper to kind of demonstrate. I was looking for exactly this kind of outcome. Yes, so that's when I developed my prompting strategy, I would need to have some ground truth data set that I'm looking at, and I would need to keep coming back iteratively with, if I'm the domain expert or someone else and say, well, what are some systematic failures that we can see? Oh, look, they're overemphasizing the all 5, we need to maybe articulate the language differently to make sure it's more consistent with how a human would read that or whatever it might be. Yeah.
Yeah, but it's just interesting that they seem to agree about the more conceptually specific things about populism. It's just how you get from there to the...
Yeah, and to your point, I mean, you could also give it another way to do it is to have a branching structure in the prompting strategy. So this afternoon, I'll show a new project I'm working on with Emma and Cass, Emma Thomas, fairly well known in social psychology. And we have this relatively complicated branching structure in a labeling exercise on QAnon tweets. And the way that we deal with that is a more generalist question at the beginning, is it supportive or not? If it's supporting, well, let's start asking some other questions about it. You can imagine doing something similar here, like a headline, general, populist confirmation, and then we ask the more teasing out questions later. If you've got humans who have gone through the same protocol, then just do the same with a conditional protocol with the LLMs, and then you can compare exactly between those two and get some confidence about the two. So trying to overload everything into one prompt, it's sort of like conceptual populism, but it's also really a high bar and it's got to be all 5 dimensions. It's like, it probably would be better to break out those dimensions. And then post hoc, I could probably then do my own calculations afterwards. Whereas I've here got them to, sort of synthesize all of those 5 things into one answer.
Thank you.
So let me just say a few things about labelers, some of which I've already mentioned. A few comments using transformers to label. So it's really flexible. As we've looked at, models can handle all sorts of media, which is like fantastic, even in different languages, from social media to whatever. It's read it all. And so, you don't have to retrain or, rediscover a model is generally trained to do it. Extremely cost effective. If you want to look into the numbers, my estimate is it can be up to a 20 times saving on costs, paying fair wages for humans versus working with models. That can make some projects feasible, whereas previously they were unfeasible at a certain resourcing scale, which is like, a real win for us in the community. You can also get some benefits out of batch processing, just as some technical notes. So rather than asking the model to respond right now, you can send all of your jobs for labeling over and have the model respond when the platform has some downtime. You generally get a really big reduction to do that. And also, if your context is quite long, your prompt, you actually can get a cached prompt. So it means that it caches for 5 minutes your previous prompt, and it costs a little bit more to cache it, but then it's extremely cheap to reuse that. And so if you've got the same relatively long prompt going in and it's more than 1,000, you sort of switch on caching, then again, you can get really good reductions in cost. So there's a few tools you can pull to make this cost saving. As I've said, zero shot is not assured, and I think is really only valid as a bit of a appendix thing, like, this is what it looks like, zero shot, but I would not be proceeding as a labeler on zero shot unless I'd done something with the model or trained it myself, fine-tuned it myself or whatever to get really sure that it's going to work. Extended prompting is great, but as we've just been discussing, you need to carefully manage what you're asking the model to do. If the model is good at following rules, well, then construct something like you would with a human annotator to make sure that it doesn't make unintentional mistakes, so to speak, that you actually can kind of net out what's going wrong and where it's going wrong and isolate that, focus on a better prompt and then move on. And you can always do post-production analysis. Ensembling can help. So something I didn't draw attention to before is over in the right-hand column here, what I've got is a majority perspective. So imagine that I did all of these 9, giving them all one vote. What would be the kind of the final vote if I gave all of them 9 votes and said, what's the majority view? You can see that the zero shot is not really, it's not bad, but we've probably still got a problem here. But notice by the time I get to the extended prompt with majority, it basically returns what my priors were going into this question. It turns out it can be cost effective to actually have multiple models doing something with some variety and then using the ensemble of those results as your sort of final labeler. And yes, it makes it a bit more technical, less effort and so on, but that's a standard way to approach machine learning problems anyway, to do ensembles. An ensemble of weaker decision makers sometimes can be more powerful than a single strong decision maker.
When I have an extended prompt, could I, because currently it's just definitions, right?
Yes.
Could I have a definition and then give examples?
100%.
Train it kind of.
Will you be here this afternoon?
Yes.
Okay, I'll show you an exactly example. The one with Emma and Cass, that's exactly what we do. We actually have basically I took the page of instructions given to humans, which has examples for the yes and the no and whatever it might be. We put that in the prompt. Particularly if you're working with a strong enough model, that's all really useful. And that moves into, I've called it extended, but in the parlance of language models, it's kind of a few shot example where you're actually showing it the task done several times already correctly, and then it's like imitate this. Yeah. So absolutely, and yes, I would recommend it. And in fact, when we were doing testing, as I'll talk about this afternoon, that becomes quite important because you realise systematic problems that the model is making, that the humans had an understanding that we didn't reveal to the model in our instructions. So, we need to add that one thing. We add that one thing in the instruction, say, and by the way, if it mentions, for example, this hashtag, it always is such and such. We put that in, and then the model, again, perfectly, just like the humans would. Yep. Okay. Now let's go to another way of using transformers. This is using transformers in a more creative way. I'm going to call it using them as detectors, which is neither encoding nor generative. It's actually using language models as language models. The original idea for our paper was going to be who knew, language models are good at being language models. The idea is that we're trying to actually use that statistical inference part to tell us something about how surprised the model is for what's going to come next. And the idea of paired completion is that we have some text that we want to label. In this case, it may be a stance or a framing of a particular issue. So, for example, it could be climate change science could be one view that we're looking at, and another view could be anti-science, so to speak. So on the one hand, it might be examples of climate change is primarily caused by human activity, so anthropomorphic, versus a denialist stance, like climate change is a natural phenomenon that's been happening for millions of years. And what we're going to do is we're not going to show the model our test text yet. First, what we do is we prime the model by giving it a couple of examples from a set of examples from one or other stance. So, for example, we prime it by giving it sentences from a pro-climate science stance. And remember, because it's autoregressive, that sequence that's already in there is already starting to change the statistical kind of view of the model towards climate science sayings. And then we show it our test text. And what we do is we look for that test text, certain models, you can actually ask it to give us the statistical probabilities for every word in the text, given conditional on already having seen or consumed those priming texts. So we sort of prime it as if these things have just been said by an expressive entity. And then if you were to follow with this text we want to know, how surprising is it? Is it kind of like, oh, yeah, this is right in the same vein of climate science? Or is this like, a real sharp turn? And now we're like a denialist. If that's true, then the probabilities, the likelihood that those words come out next is going to be much lower than if it was text which followed in the same lucid, plausible, low perplexity way. So we actually use the language model's own understanding of language to see if there's a continuation of the same thoughts and ideas or a diversion from those thoughts and ideas. And it's called paired completion because we can do this for both one perspective and the other, and then compare by taking the difference between the probabilities for these text following, and then get a quantitative number for where it sits in terms of its alignment with one stance or another. So things that are sitting basically in the middle, which is like, well, I probably wouldn't say that, but I probably wouldn't say that, it's going to be around zero. The difference will be about the same. Whereas when it's like, oh yeah, that's definitely what would be said next if I just heard someone talking about climate change science, or that's definitely what I'd say next if it was climate denialism, then we're going to get some big differences between them. So, for example, think about immigration. You might have some, and the cool thing about this is that, and the reason why we want this is because it works well in a low resource setting. And this is kind of the reason why we came up with this approach, is I don't need a whole lot of labeled data. I only need like 4 or 5 examples from one framing or perspective of the world that I'm going to use for my primings. And then I can go ahead and I can test texts thereafter. So it's very flexible and powerful with low labeling effort. So, for example, you might on immigration have pro-humanitarian statements, or you might have pro-border security statements, as an example. And those are going to be all I need to collect, and then I can test a whole, corpus of texts against this using this technique and detect whether these texts are falling more in line with one stance or another. We generated a whole lot of synthetic data to test the technique and compared it to direct prompting, which I've just spoken about before. And as you might imagine, direct prompting, like labeling with transformers, is really very effective, but A, it's more costly, and B, it has some other attributes that you need to kind of think about. So I'm just showing you here, we've got synthetic data for climate change, domestic violence, misogyny, and then an overall score. So we've got synthetic data for all of these where we know what the stances are. And these mixtural and llama k equals 2 means 2 priming sequences. So these are paired completion results versus the top 2 was at the time GPT-4 under different variations using direct prompting. And my point is that the paired completion approach is getting close to the accuracy, this is F1 scores, of the richer, quite expensive labeling from direct labeling from the models. But it's actually much cheaper if we do it with paired completion. And I'll show you here This is a comparison in terms of the input cost for the API in log scale versus the overall F1 score. Two things about this. The first is you can see that on the far right-hand side in log paper, it's about 10 times more expensive to label a whole lot of data using direct prompting than paired completion. So our paired completion best kind of results were here in this paper on synthetic data, reasonably high in terms of accuracy, but substantially cheaper. And so that kind of ticked our box for having, a low resource setting, etc. Now, just to point out, only some models allow you to do this. You need something called the echo tag, which allows you to get the model to give you back the log probabilities for the text you've entered. Not all models allow that. If, the OpenAI guys or Anthropic are listening, it'd be really great for researchers if echo was available on all of your models. So there's a vote for that. The second thing I want to mention, though, is if you do have labeled data, so one of the comparisons we made was to label data with 50, 200, or 500 examples of labeled data on a held-out test set, how accurate you would be with using logistic regression. The answer is really, really accurate if you've got the money to be able to label quite a large number of texts. Again, I want to point out, so the embedding model here is not a word embedding. This is a transformer-based encoding model, right, using OpenAI embedding models. They're really good at distinguishing between text and correctly identifying stuff. Very high accuracy, and I've already told you the embedding part is extremely cheap. What's not cheap is getting all those labels to start with. So if you can afford 200 to 500 labels, then embedding approaches are great and go for it. You'll have very high accurate and cheap approaches. If you don't have that data or you're pivoting quickly between areas, which is what we want to be able to do, then you can use paired completion and get a pretty accurate result, and it's a tenth of the price of doing it with direct prompting. But there's one other aspect. Yep.
Again, when you have social media data from
Yes.
different countries, would you then have with the embeddings to do the labeling basically for every language itself, or is it then fine?
That's a good question. Probably I would use a translation first step to bring everything to the same language, and then I do the embedding in the common language. That said, the embedding models probably can handle multilingual, but I haven't looked into it. So you could do a direct multilingual embedding. Ultimately, you need to bring, because you're going to have to provide like a regression or some other machine learning model with the vector. So that basis needs to be hopefully the same across all of the languages. Unless you say, okay, language detection, it's from this language, then we use this regression model trained on this embedding. Okay, it's this language, so we do different. I guess it's a research question, which is the best way to handle it. If it was me and I could afford it, I probably would do a pre-translation, bring them all to a common language, and then run with a model that's trained in that language. You throw yourself then onto the accuracy of the translation and the abundance of the training data. Most of the models will show you what fraction of languages they've actually seen in training. So you can get a fair indication of whether it's going to be able to handle your language. They will also usually, Anthropic, I know, do this because I looked into it when we do translation for the QAnon data set, will give you the accuracy drop on different languages relative to the main language, which is often English. And if you're comfortable with that, which is usually like 1 point, then you can feel confident that the model will be performant even across language. Yeah. I guess it's an empirical question, you need to be able to look into. Yeah.
Because I assume with the ones that are higher cost, it's easier because they perform it more, or would it be the same steps?
On different languages?
They do ChatGPT, for example. And
Yes.
I assume it's easier it directly translates.
That's true, but these are language models, right? These are actually generative language models in here. It's just that they're open source generative language models that we can get the eco function from. So it's basically how accurate they're going to be for these different languages. And it may be that this falls down significantly with a different language versus these. That said, Llama 3, when it was released, for example, from Meta, their massive claim everywhere, like we were considering trying to get a research grant, was all about multilingual. They were like, this is going to be the best multilingual language model out there. That was their, because they run a multilingual, the largest multilingual online community with, Instagram and whatever. And so they need to have a really performant multilingual model. So it may be surprising that, perhaps some of the big model houses don't necessarily perform as well as like an open source model because it's got that training basis. Yeah.
With GPT-4, I've tried practically different language. Like I tried with different language.
Yes.
The outcome comes different. If you ask in English, the outcome is much better than if you ask in another language.
In Bengali or some other.
Yeah. That's what I've noticed. And you get more information if you ask in English.
You do the prompting in English?
Prompting in English.
Rather, yes. Makes more sense. Yeah. I suspect that it's heavily trained in that, if it was between those languages.
Like for research as well, most of the papers are written in English.
Yes.
They go not in different languages.
Yep.
So that's why if you want to get use the GPT or any other models for research, I prefer English is best.
Yeah. So bringing them first to English and then working. Yeah. I mean, that's what we've done. I agree, but frankly, it probably shouldn't be like that. And there probably should be ways that we can work with other languages more confidently. Yeah. Okay, a couple more things and then I think we'll draw to a close. One is I just want to mention bias. So we actually tested all of these different methods, which includes the embedding models down the bottom with training data required. Here are the generative models at the above doing direct prompting, and then here is the paired completion approaches. What I've done here is done one of the off-diagonal confusion matrix, which means that when it's making mistakes, is it making mistakes in an equivalent way on these particular perspectives? Or is it tending to, more often than not, say that a text is one perspective versus another? So it's an asymmetry. If it's not biased, it should be symmetric between the two. But if it's biased, it will start often making the mistake in one direction. And what we found is that a lot of the larger trained generative models, for example, end up being more normalization, more likely to say that domestic violence, pro-domestic violence content was not, and more climate science denialists, so more tending to identify a climate science denialist activity. That's not something we saw with a couple of models when it came to paired completion, but not all of them. But the embedding models were incredibly centered when it came to this sort of bias calculation, which is something that I found fairly surprising. So again, not only are they extremely cheap, but they seem to be winning on the bias question, which is, I suspect, something to do with the heavier fine-tuning and alignment that's being done with some of these generative models. Getting access to non-aligned models is something that researchers sometimes might want to do, but is not that easy for good reasons. That means that they haven't gone through that kind of making them less harmful approach. Okay, what you can do with this is you can take data, for example, from just as an application that we did to Australian Hansard, so our parliament. You can take a whole lot of data, so in this case from 2006 to 2023, and you look at anyone that we looked at some prominent people who speak to the question of immigration policy. This is a really important period for Australia because we had a lot of contentious debate and boat arrivals from the north with those seeking asylum, and there was a real split in the community about how to handle this problem. Immigration, I know, is a big issue everywhere. But basically, you find that with paired completion, once we actually look at all their texts, you can see that in this case, up here are the Greens Party members or the independents were fairly consistently more pro-humanitarian and statistically so than the major parties. What's interesting is that Albanese, that's our current Prime Minister, basically went on a trajectory of being starting as, under our measurements, pro-humanitarian, and eventually he has reinstated or continued the policies of the then coalition. The biggest circles here are for when they were Prime Minister. So you can see that we've had Tony Abbott and then Malcolm Turnbull and then Scott Morrison and now Albanese. And you can see they really marked out a very strong border security message. And that was what was true as well, but it's good to see quantitatively we can capture that. You can see that Turnbull actually lurched, if you like, towards a more humanitarian approach in the last period of his prime ministership, but eventually lost out to a more hardline Morrison. Morrison too seemed to go towards the centre and lost out to Albanese at the election. It's interesting to us as well to see, you know, with this sort of approach, now we can actually think through, so the grey lines here are federal election moments. Is there a move to the centre prior to the general elections? I mean, I haven't done the modelling, but it's possible you could pick up some sort of movement before the elections, people change their speech. And with paired completion, we can quantify that on this spectrum. Okay, I'll just mention quickly.
Sorry, I have a question again. I actually have two questions. For the previous graph, I was just wondering, since the measures were obtained with paired completion, how did you choose the reference statement?
Yeah, the steps. Yep.
And then second, what is the scale of the dependent variable? It seems to go from -8 to 8. So what is that?
That's the difference metric in the log probabilities.
Okay.
So in log form, so that's, if it was around 0, it would be kind of neutral between those two periods, and then more positive would be pro-humanitarian. So we call it the text alignment task. So your text is more aligned strongly with those texts over here, if it's up here, and disaligned with the border security, or aligned border security and disaligned up here. How we chose those texts, we actually had a language model write those perspectives in this case. So we wanted a really generic pipeline where we could say immigration, and it would come up with perspectives and then fill out those perspectives and so on. So we were hands off in that regard. Whereas in the climate change approach, what we did was actually took known climate science and denialist position statements, and we distilled them using language models into 5 statements. We've done other work with the, in Australia here, the support for the yes or no, which was a voice to Parliament from First Nations peoples. We took the Australian Election Commission, we had a referendum on it. We took the yes and the no positions from the referendum information and distilled them using language models into the yes and no positions. Yeah. So I guess it depends on your application whether you want to get those reference texts from real data or generate them for some reason. These are just examples of what you can do with, paired completion. You can track, these are visualizations that are still current. So this is the climate science one. I showed the immigration one. This is interesting in the sense that for the referendum, which ultimately failed, it's really interesting from a party politics and strategy perspective. What we saw was that the Labor Party decided, it seems, to have a strategy where tons of people spoke about it, whereas the Liberal and National chose only a couple of people to mention it in Parliament. And when it comes to alignment with the yes perspective or the no perspective, it was fairly clear that we had a very cohesive, Labor Party all presenting in the same way, and the Greens were similar with the Independents. And then the Liberals actually had some split, but the leader at the time was definitely on the no camp, and similar, we had the leaders down in the no camp in the Nationals area. This visualization allows you to click in and see those features and analyse, see them at once as a prototype kind of for how you might engage, the broader public with alignment of speeches in different directions. Something I'd like to do is build sort of an observatory of narrative discourse in Australia, so that every week we've got Hansard coming in at one end and we're processing it on a bunch of different dimensions using paired completion or language models, and then we're putting out where everyone sits. Everyone has a gut feeling about the discourse and it's moving in a certain direction, and politicians are often saying, oh no, I don't believe that. But we can actually quantitatively put them on on these position statements and say, well, you actually move to the right, buddy. This is it's a method that's validated and proven. That's where you sit. These are your friends, and I hope that would be, an effort towards accountability for what people are saying in Parliament. We often, at the moment, it's basically someone writes an op-ed to say they sound like this, and someone writes an op-ed and said they sound like that. We want to be able to quantify that and actually put them on a ruler and say, this is where you sit, and it's statistically different to this person, and we can show it. Enough of my rant. Okay, so that's the end of this part about different ways of using transformers. Let me maybe go here just to say we've been through a whole range from encoders, labelers, detectors, synthesizers, and I'll mention this afternoon translators. Might pause for some questions and whatever, and the TextWaves in the TextWaves repository, we'll talk about maybe later this morning, is there's a section there where I've implemented transformers to do the vectorizing task. And we've also got transformers up here in the synthetic data generation as well. So we can maybe look a little bit closer at how they go. Good. I mean, we'll use just a little while. I might extend some of the conversation we were having yesterday about TextWaves. I tried to hold back from talking about the transformer stuff till today, because now that we've sort of met the different transformer methods, then it'll make more sense to talk about it in a TextWaves repo. To catch people up, TextWaves I put together to give as minimal as possible, hopefully an accessible pathway into doing text-as data analysis related to the three waves, if you like, of the technology that I've been talking about yesterday afternoon and this morning. So that being TF-IDF, vectorizing glove embeddings, which is word embeddings, or transformer-based embeddings. Largely, the approach of the TextWaves dataset is to generate some synthetic data, and then with that synthetic data, we get those vectors under the three different waves of technology. We then can do some clustering and visualization of those vectors. So clustering using k-means, visualization in 2 dimensions by bringing them down from the high D space into 2D, with the normal caveats that we can't capture all of the sort of interesting topological contours of the high D space in the 2D. I think yesterday I mentioned it's a bit like a shadow of you is not you, but it's something like you. So that's what we do in 2D, and the default method is UMAP, which is tries to preserve some of the topology, but an option is to use PCA, so principal component analysis, which is a very widely used approach as well. And then we also have a train and predict approach. So all of the synthetic data gets created with this interesting cyclical pathway through time. And the idea of that is that then we can do something more realistic, as if we had the history of information and we train off, say, label data from the first, in this case, say 30% of the time series, and then we predict, that is, we predict the labels of the subsequent period. And then we can calculate the goodness of fit and so on. So those aspects are all part of the TextWaves repository. And I do plan to add some more. I think I might get some time tomorrow, depending on how long we speak together for. Maybe there'll be an opportunity. I might get some time to do some adding the direct labeling as well, so that we can have a look at that in addition to using vectorized methods. So in terms of the corpus and materials, I spoke about this yesterday. To create, once you've installed, let's get up the README here. So you can have a look. Yesterday, I talked a bit about installing dependencies, setting up a virtual environment. So down here, you can see that I've already activated my virtual environment, which means it's got access to all the different packages that are required. I've set an environment variable with my OpenAI key. You don't have to have an OpenAI API key, but if you want to use some of the OpenAI models, then you will need one. I've generated my synthetic data. So I've got synthetic using lexicon, which looks like this. And as we discussed yesterday, it's really quite clunky, but it does the job and doesn't require any transformers, versus using a small transformer model. We get more lucid prose under these different areas. And I should say that in this data set, we've got 3 perspectives. So from deep democracy, mainstream democracy, and then sort of deep anti-democratic perspectives. And so they're the 3 kind of positions. I've got 100 of each, so 300 in total, and that becomes our sort of mini data set that we can work with. And now with that data set, we can run our methods. So up until this point, we've looked at running, say, TF-IDF or the glove method. which is simple by just putting in the method like this. So we looked at TF-IDF yesterday in Glove, but we can also now do, if we want to switch to a language model method. So for example, use OpenAI embeddings, and I can direct it to use the LLM dataset instead of the lexicon-based one if I just use data source LLM, as it says up here, as a switch. And hoping that it looks like I've got the internet and my keys in place, we should be able to run this and see that we'll start sending out OpenAI requests to an embedding model. In this case, where you're going to use the small embedding model from OpenAI. What's it going to say?
Data.
Let me check what I've got.
Data source, not data.
Oh, thanks. Good. Let's try not have a typo. The small model for an OpenAI embedding model is really cheap. It gives you like over 1,000 dimensional vector, and let's see. So I think at the moment we might be regenerating our, shouldn't necessarily be regenerating, we'll see. Wait for it to execute. While it's running, we'll look at one I prepared earlier. So let's see, outputs, figures. So yesterday we looked at the scatter plots for TF-IDF using the large language model, using the large language model dataset, and we compared it to, say, the Glove outcomes using the large language model. As you can see, it's continuing to go there. So it did create some synthetic data. And then we've got, today we can now have a look at the other methods. So we've got, that's SBERT, which is sentence BERT. So that's the BERT model as an encoder. Or we've got the OpenAI small embedding model. And that's just updated. And what I'll try to do is put them alongside each other. So let's put up the TF-IDF and the Glove. The thing that you notice with the OpenAI embeddings is the how precise in the 2D version the clustering is for the deep democracy, the anti-democratic clusters. You can see it's actually identified there's probably 3 subclusters there that are really like linguistically or semantically related. It's not just one amorphous one. I haven't seen that in any of the other embeddings that we've done with TF-IDF, Glove, or even SentenceBERT. The larger dimensionality and accuracy of the OpenAI embeddings is pretty remarkable, and actually has found these 3 subclasses. And you'll notice that makes 0 mistakes. So there's no anti-democratic one that's hanging out somewhere over here. They're all very precisely identified within those areas. that's one approach. The next question we can ask is like, how does it go in terms of time series? So remember that not only do we get the scatter plots, we've also got time series where with the, let's make this a little bigger. So we've got a time series that's produced. And remember, this is using the 3 labels, and each of the text, the kind of synthetic tweets gets given a timestamp, and these timestamps are created in this time varying sinusoidal way so that we can create this fictional time series through space. And we've got a train test split here. So the first 30% is what we use for training. What we mean by that is training a logistic regression using the embedding vector as the right-hand side variables, predicting which label, with what probability the outcome will be either deep democracy, mainstream, or anti. And we're using the data, the vectors from the first 30%, and then we're going to infer the labels for the remaining 70%, as if these were in the future, and that allows us to compare to the actual ground truth. So when we do that, I'll show you the comparison. So let's see, for example, with the OpenAI embeddings on the LLM data, and we'll compare that to, say, the TF-IDF on the LLM data. The OpenAI embeddings are essentially perfect on the anti-democratic stuff. There's no distance between the ground truth, which is this transparent, thicker band, versus the inferred predicted, which is the sharper colour, bolder and smaller. You can see that you can't actually see, in this case, the ground truth, because it's right on top of it. You can see there's a little bit of the ground truth in here for the TF-IDF approach. But, you know, between these two, I guess it's probably not immediately obvious which is the better prediction tool in this context. Perhaps this is following some of the peaks a little bit better than down here, but, you know, it's not certain. There's going to be a variety of reasons why, you know, some models will succeed or not under different settings, but it's a nice way to compare them. And what you can do is, if you run all of the, in this little example, if you run everything together, so I'll go back to the README and show you. Let me put it up here. If you run the build all function, which is down here, then it will also produce for you some summary information. So you'll be able to see a summary. So, for example, I'll have this running in the background. We'll let that run for a while. What it's going to produce is a summary of outcomes for different metrics across the different methods. So you can see here the data source is LLM, and then the method is from the TF-IDF vectorizer, the glove vectorizer, the sentence BERT, or the OpenAI, if you've got access to OpenAI. And these are the different scores for ground truth comparison for the clustering, versus here we've got the accuracy and the weighted accuracy on F1 for the prediction model. In this case, you can see 0.84, 0.79, 0.85, 0.88. It is that the OpenAI embeddings give a better prediction outcome than any of the others. But it's not an obvious, like, you know, if you like, from the history of these representative vectors. It doesn't go, you know, lowest always in a linear monotonic way to the highest. You can see that the glove embedding vectors in this particular setting doesn't do as well, it seems, as the TF-IDF vectors, which is, you know, again, there'll be a number of reasons for that. have a number of things we can probably optimize. We probably should expect it to do a little better, but comes down possibly also to the quality of the texts that are being produced, etc. And if you want to see those outcomes, coming back to the README, if you want to then visualize the results, then there's this other little code that you can use, which is this results one. Let's just give myself another environment here. So reactivate my my virtual environment, and then I'm going to run this again, but we'll do it with the language model. So that's the language model summary table that's just sitting in here. Then we also get a nice graphical representation of the same scores. So you can see there exactly what we're looking at before. And here the adjusted range, normalized mutual information there about the clustering relative to ground truth, and the silhouette score for the quality of the clustering for the in-cluster versus out-cluster relationships. Again, just as an example, probably isn't going to go on your paper, but this is the kind of things you can do. And you can look at that results. If you want to see about plotting and so on, you can look at the results code for doing that. So that gives us the kind of current state of the repo, which, as I said yesterday, goes through these different steps. We had that in the slide over here. So from synthetic data generation to vectorizing, clustering, training and predicting, and then visualizing the performance. So as I said, what I'd like to add to this is not just a vectorized approach, but to do a direct labeling approach on the, as if the tweets were kind of coming in, you would keep labeling as they came in, and then we can compare that as well in terms of its accuracy. And the variation there might be that we could use different models. So at the moment, I'll show you I don't have a prompt for that yet. So we could do it in zero shot, we could do an extended prompt, and we could try different models. So at the moment in the code, what you'll see is that you can control, for example, the model that's being used to produce the synthetic data. You can also control the model for the embeddings. If you go up to configs here, it's called a YAML file, which is all the defaults are held in here in really simple plain English. If you want to change the defaults, then you can do that, and you can see you can change the different models that are being used in here for the different versions if you want to. These are controllable as well in the code, like in the kind of model calls, but these are the defaults that it's using, which is a useful way to document science as well. Yeah, there you go. So that's like, now that's with the transformer part, that's the TextWaves repo. And hopefully it's useful to play around with and practice with. Yeah.
So it looked like different models performed differently well for different things. So would you suggest to always run like your models on two different, or your data on two different models to kind of balance out the accuracy? Or
yeah, so whenever I reviewed a paper, what's today, Tuesday, Sunday, Monday, like I was on the plane and then finished it on Monday. And one of the first things I said back to the reviewers was there's no comparison to a baseline model. So they'd only use their sort of best final approach. And I said, okay, that's fine, but like show me how the performance changes with a different model, and show me what's the outcome with sometimes what's called a 0R model, which is if I just choose the class which is the most prevalent and I say that's the thing all the time, how wrong would I be? Because if your accuracy is like 0.78 and you're like, oh, great, let's go. But then I show you that a 0R model, which is just predicting, like every time says it's the most dominant class 100% of the time, gets an accuracy of 0.75. Suddenly your 0.78 looks different to what it did before I realized that. So what what I think is always helpful to do is, and this is why, like TF-IDF, for example, is just so easy to set up and run if you're in a labeling environment. It's good to have some, it's quite nice to have, when we did, for example, the paired completion work, we wanted to show examples from each of the major sort of technologies to compare it against, because I mean, that's a methodological paper and we're trying to say, here's a new method. So it's a horse race paper. So we need to show it against all the methods. But I do like whenever you're doing a social science application, it's probably not in the main paper, but it's like, show me that the performance for your particular specification is like how it compares to other approaches. Because there are trade-offs, right? So as we were discussing yesterday, the TF-IDF approach seems like trivial. It's actually kind of very transparent. It's so much more transparent than anything here in terms of like what is going on. There's no way that anyone can write in a paper in enough detail or even humanly explainable text what is actually going on in a word embedding or like transformer embedding model. It's not possible. It really is a bit of a black box. Whereas the TF-IDF, I can say, hey, look, I counted things up. I did, a little bit of maths when I worked out how many were in this article, how many of these were across articles. That's adjusting for abundance and scarcity. It's all understandable. Here's the vector. Every position in that vector is a word, and I just counted them up. It's fully transparent, and it's really easily to implement. It's like one line in, the sklearn or other data sets. So just showing it as a comparison is like kind of, I think, yeah, preferable. Yeah. And when it comes to your model specification, what we like, I'll talk about this afternoon with the QAnon work. What I'm doing is doing I think I have 9 different models. So 4 from Anthropic and 5 from OpenAI. And we have a ground truth data set of 1,000 really well, high quality labeled tweets. And as I discussed this afternoon, we put aside 100 of those, like a development set, where we can look at the labels, we can do everything, and we can test and test and test. And that was all about refining the prompts and putting in examples and all that sort of stuff, and getting the costs, trying to get estimates of the costs. And then when we were ready to test them, we test all of those 9 different configurations against the 900. And then that will go into the paper as like an appendix to say, okay, here, and I'm trying to get basically some of the methods, some of the models will be probably not performant enough, and some of them will be like really, really performant, but extremely expensive. And so I want to show on a small scale why we made a choice at this level for our baseline results in the main paper. And that will be the model we then go and do 100,000 tweets on. Yeah. But it gives comfort to the reviewer because, as we've been discussing, as much as we'd like to talk about like how cool the tech is, the reviewer is typically going to be reviewing us and reviewing each other on the basis of the quality of the findings about the research question. The method just needs to be trusted and understandable. And so a trusted method should be one that we can show a little bit of context around it to show why this method and not that method or that other method, how it compares. Always gives comfort to us that, okay, it's a reasonable choice. Yeah. And if you're moving within one model family, like in OpenAI, for example, or Anthropic or whatever it is, it should be one switch that you change and you get a whole new set of results. So I know as a reader and you know as a writer that it's pretty easy for you to run this again with a lesser model or a better model. Yeah. So it's a long answer of saying yes. I think you should try. It's good to try. It's good to demonstrate some methodological flexibility so that we can validate or we can impress upon the reader that these choices we've made come with some context. Yeah.
And with the TF-IDF, just to clarify, I've understood correctly yesterday, because you're basically directly specifying what goes in the model, what words it's analyzing, right? So that is not accounting for if I'm analyzing data with any typos. It will just, if there's a typo, it will not count that specific word.
No, so the way that TF-IDF is usually implemented is that we set some filtering boundaries for the words Okay, that's the entire vectorizer. You can see it's like not a lot. That's because we're using the sklearn module, and it has TF-IDF vectorizer as a one-liner code. But what's important to your question is see these settings. So minimum DF and maximum DF. So what we're saying is that we don't want to take. So your question was about typos. So if the typo is being made across a lot of documents, then it may be important that we include that in our vocab as a word. If it's not a stop word or whatever, like that gets hit by that. Because it's basically, it's a feature. The way of thinking about a TF-IDF vector is that every word is like every unique word that survives getting rid of the stop words is a feature that we're going to use possibly that has information content. So for example, if the research question was, which is TF-IDF have been used before, authorship. So for example, the founding documents in the US, there's a lot of debate about who actually authored some of them and did, one of them author other people's documents, or on the Supreme Court, there's questions about, do associates working within the offices of one of the judges actually write to the judge. So one of the things you can do is you can do an embedding or a TF-IDF analysis. And if you find that a particular author has a typo that is used more often than not, that's a really important informational feature that goes back to the authenticity of that document. And what usually happens, and what's going on here, is the vectorizer is discovering the vocabulary, the unique vocabulary, from the corpus itself. So if there's typos in there, that typo will be one of the unique words that forms a feature in the corpus. It's so one usual method. However, if you have done it slightly differently, where you have more control over the dictionary, the corpus, the words being used, or you do a TF-IDF vectorizer on corpus A and there's no typos, and you take the same vectorizer to corpus B where there's typos, that typo thing will not be recognized and will not be one of those words. Yeah. So it's like a yes or it's a yes or it's a no, depending on how you set it up. Yeah. Yeah. I think the question I would be thinking is, like, in all of this is what's important, what's an important feature. And that's why sometimes the stop words like, the, is, at in English usually get dropped out. But there are some applications where it's like, actually, I want to keep, personal pronouns, because that like the perspective of the writer might be an important feature for identifying a particular thing in your documents. Yeah, sometimes in some settings, first-person perspective versus third-person perspective becomes an important feature to sit on. So you're not going to drop out that sort of information. Yeah. Yeah, just to complete the story. So here, 0.95 is we are going to drop the words which are in more than 95% of the documents, because they're probably going to be not very informative. And we're going to only include words that are in at least 2 of the documents. So if there's like a word that's idiosyncratic to one document, there's not really much point having it in TF-IDF. Yeah. And the n-gram range means I'm including individual words, so that's 1, and paired words, so sequences of words, which is every single sequence that survives getting rid of stop words. So for example, Australian Parliament will be included rather than just Australian and Parliament. Australian Parliament will be its own token. I think that'll probably be the simplest version. Yeah, I don't know if we should be measuring simple by lines of code.
So for all of these different methods,
Yep.
you can, after you've done all of this, the outputs themselves can then become inputs into other
100%.
analysis.
Yeah, exactly. Which is kind of what I was getting at before with the value of vectorizing your data set. So this between your text and vectors can be all kinds of things, right? So we've said TF-IDF, word embeddings, sentence sequential embeddings, etc., and transformers. That will just improve the quality of the space that you've put them into. But then once they're in this space, yeah, there's lots of downstream things that you can do with that. And some researchers will just continually be compiling, like have some method for every day or every week, bringing texts that arise in the world into a text database, of which there's now, into a vector database, of which there's now providers. So the big model providers have vector databases, but there's even third-party vector database companies. So like for Astro, I use a company called Pinecone, who their one job is like providing vector stores for text vector databases. And it means I can query it with an API really quickly, and you can have metadata, you can do all sorts of cool things. So that's now like a software as a service is actually a vector library or database. So that's exactly what we do. I just noticed, because it's the change of the month, I will run a query against Monash's research papers API, get all the new ones. There's usually like 600 that come through in a month. I will vectorize them, push them into our vector store, and that's all I need to do, because at runtime on the front end of Astro, the app, when someone puts in a query, it vectorizes their query and then does a semantic match, which is available in Pinecone as a function, against all those vectors. And that's all I needed to do, was add more vectors to the vector store, and every query from now on is improved by having more vectors in there. Like it'll find those additional, information and then serve them and go through the pipeline.
So when you bind two vector spaces, are you fusing them so that the original space is changed by it? Is it being retrained, or is it?
No, so there's no. So that's static. So it's a deterministic process. Once I've got an embedding method, the sequential embedding method, TF-IDF is slightly different, because once you add a document, all the document frequencies change because you've added a new document. So it's not stable. Whereas the word embeddings, when you're putting it through the trained word embedding model, as you are with a sequential embedding, like a transformer-based one, it's basically a deterministic process. So the text goes in and out comes a vector. It doesn't matter what else it's done before, like that vector. So it'll keep coming out exactly the same again, which is really neat. So when you add data, when you add new vectors in, it's like adding dots on the map. The map is staying the same. It's just adding more dots. Yeah.
But what if something changes somewhat dramatically, like we were saying yesterday, and you feel like somehow the vector space itself needs to be retrained?
Yeah. So that's different. So that would be where if I had fine-tuned on a corpus to shrink wrap this vectorizer to that corpus, the map it produces now will be the same forever of where I put things through. If I think, hang on, the map is distorted in some way or not capturing effectively new things that happen in the world, I would fine-tune, and every point on the map will move slightly. Yeah. Some things will get further apart, some things will get closer together in that high D space.
Under what circumstance do you think that's a justified thing to do?
Yeah, it's a good question. So it's a question of concept drift, which is like, when do I think that the underlying semantic world has shifted? So the Geometry of Culture paper uses it to their advantage by effectively showing that shift in semantic space over time through shrink wrapping to those decadal word usage. When is it justified? Usually when performance, so misclassification rates are going up, which usually indicates words, new vocab has entered the lexicon that aren't currently being represented, or meanings are shifting. So the existing words are still there, but the used meaning of them is now different to what it was when I froze that knowledge of the language when I trained it. Yeah. So I guess, yeah, like if there's an infusion of a language group or a subculture, or there's a political speech or something that starts to really impact the way that subgroups are talked about or issues are framed, then maybe that's a trigger.
It's a very much judgment call, though. Like,
Yeah, so that's why I said misspecification. So as long as you keep training ground truth every month, like imagine you have ground truth and you're following the model's ability to predict off that, and you start seeing a drop off in performance. One of the reasons for that could be that your frozen vectorizer, it's like the same with any generative model. They have a training window. It's like they know up to, you know, October 2024. Anything that's happened after that, they should say, sorry, I don't know. And it's the same with these. These are also got a training window. They're trained up to a certain point. Anything after that, they have no idea. And they may misspecify where things are. That includes things like, you know, who's currently in political leadership in a country. If you put in the name of that person, it might today associate it with closer to the vector direction for political leadership, whereas 10 years ago or 5 years ago, it might closer associate it with business leader or, you know, parliamentarian. If you put that name in, because it will have read and seen that name before, but it will not have, it doesn't know that that's now associated because it's not read articles using it in phrasing, which says and indicates that it's now political leadership. Yeah. So I don't think it's a subjective judgment call. I think it can be a quantitative call, but it does need refreshing ground truth based on current, like contemporary examples.
and this ground truth, is it generally like
Human labels.
domain experts?
Yes. Yeah.
Labs?
Yeah. Somewhere along the line. So, yeah, I mean, you can probably plausibly say, you know, we ran it through GPT-5 and generated, or, you know, some high effort model, and it cost us $1 every time, and say it's as good as you can get, possibly better and more reliable than a human or something like that. But you're always open to the possibility that, I don't know, it's not as domain expert as it should be. Yeah. But maybe you could use that as an indicator. So, you know, once the model is if it starts making a higher, like your ground truth tested through your system starts to have lower performance, then you'd be like, okay, now I need to bring in the humans and let's start doing this properly.
Right.
Yeah.
So I was like thinking about the example you had about the left front.
Yes.
And I was thinking also, for example, in France and in a bunch of places, you had right-wing populism
Yes.
present for a while before left-wing populism
Yes.
sort of started
Yes.
coming into
Yes.
the scene. So if you were training your data before the left-wing populists really came on
Yeah.
the scene, populism, the universe of populism is right-wing. So if you're looking at left-wing populism, it's going to get confused
Yeah.
because it's
Yeah. And that's
populism, but it's not.
so that's a really good warrant for fine tuning on your corpus. So if your corpus includes left and right wing populism, then I would, you know, steep my model in that. And I mean, for example, at OpenAI or Anthropic, you can take their embedding models and you can fine tune them to your data set. So you can save your fine-tuned embedding model based on, and then call it through an API. Yeah. So it's an example where even though it's not an open source model, which is downloadable, they allow you they'll do the training on their side and then make an access point to your model.
That's helpful.
Well, it's business. It's business. Yeah. But yes, it is helpful. I mean, it's helpful for them, it's helpful for us. It costs you much money. But largely, as I said before, dealing with embeddings is like 100 times cheaper than dealing. I mean, I don't know what I show you the log scale, but it's hard to express like how much cheaper it is to work with embeddings. Okay, so
3, 4
yeah,
orders.
1, 2, 3 orders of magnitude. Yeah, like mind-blowingly cheap. But right, these all require embedding models need ground truth to train a classifier. Yeah, whereas that's the benefit of everything here is actually like few shot or zero shot. Like, so yeah, I guess it's the, you know, and so that's the design decision is like, if you want to use your infrastructure to always detect one or a few things like for the foreseeable future for the next, 10 years, then ground truth and having a ground truth approach is probably worthwhile. But if you want to have infrastructure that can move fairly quickly between, different perspectives and views as they crop up, and, you want to be able to like quickly do an analysis of how people have treated this issue for the last 5 years because it's pertinent to a research question, then you want to be able to like effectively sit at your desk and like, here's my new direction I want you to analyze, go. And you don't have to call in the experts and the, like, yes, would you be able to do it? Okay, I'm going to prepare the stratified sample for you. Okay, how long have you got to do it? And are you going to go on to like one of the, online labor force, platforms, or call in professor down the hall? They're kind of busy. They could maybe get to it in summer break. And yeah. Yeah, I mean, I think,
Sorry.
I was going to say in the end, like all research, these tools have the same set of constraints and implications like cost, time, flexibility, technical expertise, sustainability. Like, will I be able to maintain and hold on to this if X, who set it up, leaves? Yeah. Sorry, you were going to say?
I was just wondering, like, is there any kind of contraindication for how we can use the outputs here? So like, I'm imagining, okay, you use some of these methods and you get some output, and then you decide, okay, I'm gonna plug what these classifications, for example, into a multi-level model with some like public opinion data or something like that. Or I'm gonna try and do like a classifier for the classes with some other stuff from sort of averages at the population level from public opinion data. Is that something that, the design, well, I guess we're going to talk about design later, but is that something that you shouldn't be doing because it's already been done? Like you've already done something classifying, classifiery before or something?
No, I think that's fair. I mean, like everything in quantitative work, you just need to know what are the likely sources of error. Is it going to lead to what kind of contamination? Like, is it going to be biasing my estimates? Is it going to be inefficient? Like what kind of problem am I dealing with? All estimates have error. Is it likely to cause, underestimate, or is it overestimate of the effects? Usually in a lot of situations, we can argue convincingly like, these errors are probably just going to underestimate, like the impact is probably larger, like it's a conservative estimate because of the ways that, X, Y, Z has been done. So yeah, I don't, like, I think that's the point of this, is to go from that world of like unmanageable, unusable to some extent text to be able to play games over here, like now with new columns that come from wild pipelines with all sorts of crazy stuff going on, text as data, whatever, but we get another column and we can now work with that in our, estimation model or whatever. Or we have, a better column than, the two we had before, which were all proxies for something we really wanted to measure. Now we actually have that, because we're able to convert real ecological, a universe of utterances, speeches or whatever into actual like data, and now we can use it in our model. So I think these systems should impact the models we pose, because often the ways that we've previously done quantitative work are heavily constrained by what people have done before because of what was available before. And so when you see, you know, in economics, people doing all this work on country level statistics or surveys, and it's hard to break out of that mindset and say, actually, like, we could actually use like really micro level data. What would a model look like now if I had access to that? So sometimes history is not that helpful because it's too constraining in terms of like your mental models for like what's possible. Yeah, it takes a bit of creativity, a bit of like reframing of the like what we're doing here to be able to say, actually we could do this now. Like that's a whole world. We haven't asked all these questions about that now, you know. But that'll go to the validity of the system you've used and is it trusted? Yeah. How can you convince the reader that that new column is a valid set of data, or at least as valid as the column next to it?
Wondering if we can also use like some of these methods to do simulations of, for example, networks of agents. So if you have like text data from all your parliamentarians and you have relational sort of network data from like when they met with each other, for example, like from an events database, let's say, and you feed that into some kind of network or agent-based model, can you, would that actually, like in terms of the underlying math, would those clash or?
No, that's fine. So, yeah, I mean, this afternoon I touched a little bit on ABMs as a valid, I think, approach to the complex systems question of social change, inertia, and so on. The combination of those worlds, so ABM plus LLMs, is a new move, which is not many people have got the capabilities to do, but it's very much possible. So using LLMs as agents in an experimental setting, so you can give an ensemble of different agents their own persona to play, and they can then have interactions, whether it's through game theoretic or, you know, turn-based play or speeches or whatever, and you can have that playing out as an artificial world, but still with the control of a lab, because you've built actually, like, and that's now some of the papers emerging, they're actually saying not only, like, so rather than having to do this with humans, which one of the challenges with humans is actually finding enough humans who believe in the tail distributional perspectives. So yeah, like, I mean, the QAnon paper I'll talk about this afternoon is emblematic of that, like to try and identify enough humans who actually are willing to tweet or have tweeted about, you know, all the indications of, you know, collective action and, you know, harm indications and so on. It's actually a tiny number in the data set. If I go and do experiments now in a world in which I can actually have a dial for how many hold that perspective, instead of it being 1 in 10,000, I can now count 100 of them and see what goes on in a network when I, you know, increase that level. It's super rich for like a scientific platform, because you can explore things in ways that you previously very difficult. And the thing is that often, or for example, in that situation, the communities where there might be higher incidence of that perspective are almost impossible to get research access to for various reasons. They're usually quite closed or, like effectively like gangs, right? So like, it's...
Tried doing some research with identitarians in Austria and got nowhere. Got only like 4 participants.
Yeah. And even then, you know, if someone signs up to a survey online or something, is it really an authentic individual who holds these views, or like, I don't know, someone who's unemployed who's like seen a good way to make $20? And can take on a persona. So at the very least, testing your rig with, you know, if you're going to go and spend lots and lots of research dollars on something, now LLMs are being used to, for example, like the Australian government's considering adding some surveys that specifically get at questions around democratic resilience. And previously you would test them on, focus groups and try and get validity of questions and see how they're answering. Now you can actually do kind of stress testing with LLMs answering and push LLMs to take particular perspectives and see how the survey, withstands that in a quantitative sense, which is, pretty handy. So I think we're going to see a lot more of that, and probably a lot packaging up. So rather than, individually us having to all learn how to make, an agent, an LLM-backed agent, which does this or that, there'll be sort of turnkey agent solutions where we can say, okay, here's some dials. I want to have a world in which there's this, this, and this, and this, and I want to run, this survey against it, and someone will have created a platform to do that. I mean, that's probably going to make some money if someone does that, but that's what I would do. Yeah.
Exciting. Does anybody else have any questions? Sorry, I monopolized the space for a bit. We still have like 15 minutes before we break for lunch. If anybody thinks of any questions, please feel free to raise your hand or write in the chat. Otherwise, we're just chilling.
Yeah, that's great.
With the training data, it looks like in one of your graphics that it's about the absolute number of training data, or is it also about the percentage that if I have a big data set, do I need to code, for example, a certain percentage, or is it really about the absolute number?
That's a good question. I guess it's both. So in machine learning terms, normally a rule of thumb is 30 examples of the smallest class. So that can be intersectional classes. So, whatever, gender this and age this and, this perspective and this political party is like, imagine a decision tree. How many of those have I got in my data to train off? Usually you need the rule of thumb is about 30 to get like a reasonable estimate for whatever is the variables that select for that class.
But 30 of the intersection. So
yeah, that's right.
You have to have 30 females, breaths.
Yeah. So imagine partitioning up your space across 3, 4, 5, 6, 7 dimensions into boxes. How many do you have in each box? So machine learning people will say usually about 30 in each box at minimum. So that's the sort of count argument. That can't be the solution though, because you might have 5 million or 10 million people, right? So 30 is like presumably not very many. And that's where the percentage comes in. What's less important than a raw percentage is the distributions. So it's really important to be able to have adequate coverage across the support of the distribution in the training information, because whatever you train on is like what the model can now deal with. And if therefore getting those, so a common but not very good way to go about this sort of stuff is some people will say, oh, I did a 70% train, 30%, validation or test split. And maybe that's because it's in the software as a default and they just pull everything together and off they go. The question that you then need to think about is, well, okay, but surely all of those observations are not like homogeneous. There must be characteristics that drive each of those observations. So rather than just a uniform random split, maybe we should be doing stratified sampling to make sure that we've got in our training data representation from at least some of the cohorts, if it's a continuous like an integer or something between 0 and 100, then I might partition them into, percentiles or, like quartiles, and I have a representation from the 4 cohorts, and I actually stratify the sampling on that basis. So in the training data, I've got someone from, low, medium, and high across all of those different characteristics. That is probably what I would be focusing on, the quality of the training information rather than so this is probably a little misleading, but it's a good question on the basis of it. This case was like synthetic data, and there is no one behind these. Like there's no characteristics, there's no metadata. They're just rows on a page with text, 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 text. There's no comma, comma, comma for what else these people have. There's no people. So that's why in this case, it simply is a case of more is better. But in most realistic situations, more quality is better. And that's where being careful about that representation within the training data. Yeah. So at that point, is a 5% sample enough material to get at the distribution that exists in the 95%? Probably not. And that's where you need to kind of do some analysis to draw out where that would be on the characteristics of the data.
So would it be fair to say that the diversity of the sample is just as
Yeah,
necessary as...
Correct, yeah. That's a good way to put it. Diversity of the sample should be as close to the diversity of the, of the inference area as you can. Yeah. I mean, abstracting from that specific application, the current model advancements in terms of performance, there isn't very much left on the table from an architectural perspective in terms of fine tuning or model size. Like most people would argue that that's largely, been exhausted. The lever that is being pulled at the moment is quality of the data. So the big advance between like the previous to the reasoning models that say, for example, in OpenAI, if you look at the model release criteria, yes, they include what's called chain of thought, which is the model is speaking to itself about how to think about the problem, planning an approach, doing the approach, critically reviewing that before it eventually gives you the answer. So it's gone through this whole sequence of tokens, which is it talking to itself about it. And that seems to generate a better answer. Maybe you could say that's an innovation. But actually, if you read closely, the big deal is that they changed dramatically the data from as much as we can get all of the internet to, oh, hang on a minute, a lot of that is like rubbish. We need to actually close down the sort of just random junk stuff and focus on really high quality. So they did deals with publishers of academic journals to focus squarely on the highest quality text sequences they could get. I mean, if you're an academic and you're in mood to be depressed, then it's kind of like, not only do we produce the journals and do the reviewing and edit, but now we're actually also, apparently our work is now training models that people are making money from. So it's just, you can get in line with the creatives, the book writers, and everyone else who feels exploited through that system. Now, they might argue, well, hey, we've got a publishing agreement, buddy. Like, we're the publishing house. We now decide where your stuff goes. But so just as an addendum to the quality question, models are getting better largely now. The core issue is quality of training data. And that's because it goes back to any machine learning or inference modeling technique. The quality of the data is that you expose it to is absolutely key. Yeah.
But does it then not depend on, then I would have to look at the whole data set to know how good my sample is from the quality, right?
Yeah, so you need to get some characteristics from the data set and then to do a stratified sample. If you've got it, you're in a real bind if the whole data set is going to come in 10 years and you've currently got 3 years of data to train on and you're going to do inference for the next 10 years of months because I don't know what is going to be the future. So that's where we need to look at the characteristics of the data that's arriving and see if it's still meshing. And that would be an argument to then say, okay, we need to probably retrain. Yeah. And what often happens if you're doing inference like that, which has got a temporal component to it, usually on some cadence like quarterly or half yearly or annually, you're actually doing model retraining. So you're taking in the last month, depending on how much effort and cost it takes to retrain. Sometimes it's nightly. you're like, okay, new data comes in, retrain all our models, and now infer for the next day, and so on and so on. Yeah.
Yeah, I was just wondering with like really big data sets. Let's say I have 5 million tweets.
Yeah.
And then obviously I cannot look at 5 million tweets.
No. But
And
yeah, you can.
then it's the only thing that I could do is randomly pick out of these 5 million and then look at them individually and train the data. Or if I have no clue about the data at all, but I want to, for example, see, okay, what are they mainly discussing? Then I basically have to rely on the model to already help me identify, right? Because it's so big that I cannot look at it.
So let's say it's a really big data set, like there's 500 million or 5 billion, right? So if it's only text, then yeah, that's a real challenge because the techniques you'd use on a data set that big are usually, I would say, out of local memory and into cloud memory is how you usually deal with it, because it's very hard to run like any kind of method on 5 billion rows in memory that you'll have in your computer. But you can have it in a data store like on a cloud system, and then you can run SQL code against it, and it abstracts away the map reduce sequence that you'd normally need to set up for extremely large data set. So I'm familiar with AWS. We use it in the lab, and I use it at the Observatory. They have a concept called Athena, which allows you to run, it's like BigQuery on Google. So you can run an SQL query against a very large amount of data sitting in a bucket. And so if your example is one where you've got 5 billion of these things and there's some metadata, so there's time of day, there might be a hash, like there might be the characteristics of the account, when they joined, where they are located, something else. Then you can actually think of running some SQL against that to do a stratified sample, even though it's extremely big. If you just have the text, then probably the first approach is to do something that will work in SQL to come up with a topic. So for example, it could be the length of the tweet is obtainable. You can do a number of string functions in SQL, on data at rest. So length is fine. You can extract out some indicators of topics. So you could have some keywords. If mentions these things, then this topic is a yes. And you can put that all, that's just a simple string search and do that. So you can imagine constructing that metadata at scale, and then that gives you your stratified sampling approach is one way in. Number of hashtags used, is this hashtag used, would be ways that you're going to get a handle on it.
I will have to reflect on what good quality data might look like for me.
Yeah, what are the likely characteristics that will matter when it comes to thinking about diversity in my data set? And you might have to construct some variables simply that will run in, say, SQL at scale to do that. And then once you've got your sample, now you can put it in local and you can do lots more with it.
Hello, everybody. We're back.
That's it. Okay. Okay, so I guess for those online or still tracking with us in maybe the recording or whatever, the plan for this third session is less about tools and methods and more abstracted about concepts and approaches. And I will be sharing at some points, examples of research approaches using the focus here on kind of ecological data, so things out there, and I'm going to give a bit of an entree into that. But my kind of aim is to maybe give some reflections from my experience about how, maybe it's the art of the science or something like that, and how to think about big social science research projects and some of the considerations along the way. So these will be just my reflections or thoughts, some way of handling it, but hopefully, as I said, it's a bit of a conversation starter, seed some ideas and maybe a little bit of inspiration for what could be. And I think I expect quite a few questions about parts of the story that I won't tell all of the story when it comes to some of the things that I've been involved in, but by all means, if there's questions like how did that get started, or how did you get the initial funding, or how do you sustain the funding, or How do you deal with, engagement or industry partnership, or how did you end up, providing data to the UN every day? Like, what was the pathway to get noticed by certain organisations and groups, like, so on? Then that's all conversation to have. Okay, I won't go back over who I am and Soda Labs in much detail because, I've done that twice already in the first two. Just to orientate where we are, this is the third of the 3 sessions. So the first 2 were on the kind of 3 waves in text as data methodology. So bag of words, methods and approaches, word embeddings, and then this morning we talked about transformers. To reiterate, my kind of claim for the first one was these methods are still important, even though, yes, they've been somewhat superseded by transformer-based technologies, but there's reasons why you want to stick with them, or at least have them as comparators to things you might be doing with more elaborate technology. Transformers, my message here was it's not one approach, it's a toolbox, all powered by the transformer block, and it's good to be aware of the different expressions of this new technology and how they can help with our research flows. Okay, and then so right now, this stepping back, theorising about ecological analysis. I'm going to talk a bit about systems thinking, looking at some ecological data and example approaches. I mean, in some sense, we've already done that, but I often have been saying, wait till the afternoon, or I'll talk more about that later. That's going to be now. I'm going to mention about safety and the dual use conversation, which I think is important, particularly in social psychology or areas of consideration of identifying otherwise personal beliefs or protected information about individuals and being able to demonstrate that's possible from digital footprints, so to speak, in ecological data. And then at the end, I'm going to finish by maybe that's the sort of bigger fish, which is maybe actually the answer or part of the answer to a large-scale social science change and inertia problem or challenge is actually building your own platform. And I will give an example of what we did with the Monash IP Observatory and some considerations about design thinking in building your own data generating platform, which I'll say at the outset, looking back, I mean, I'm the right side of 50, but eventually I'll hit 50. It's probably to the moment the most significant thing I feel like I've been involved in research is the observatory work, and I'll get a bit into reasons about that later. But at the outset, for sure, it was seen by us to some extent in our fragile minds and hearts, and certainly by others, as like a waste of time. Why would you do that compared to the kind of traditional research pathway? Yet there was something within me, a little fire that said, no, I think this is important. We should go against the stream and do something that other people aren't doing. And I would say it's kind of crazy for a junior person maybe to do, but I thought, let's go with it. And I've invested a lot of my time recently, and therefore not a lot of times, in some sense, producing traditional research outputs, building something like the observatory platform. But I don't regret it. So we can get into that at the end. And of course, TextWaves is there, but we're going to talk less about that now. Okay, so let me move from sort of this conceptual diagram, which I've been, labouring in terms of, making sure we focus on the research problem and so on. And now I want to kind of move to this bigger kind of question about like abstracting from that to something that's not focused on pluralism, or democratic resilience, but is sort of a template for thinking about a large-scale research challenge. So no surprises, my left-hand side starts with theoretical conceptualization. So what's the theory? What's our concept of what we think is going on here? And when it comes to large-scale questions, usually actually the more important question is, what is the system? What's the definition of the system? What kind of system is it? What kind of dynamics do I think it has? Is it a complex adaptive system? Is it linear? Is it bipolar? How many states? Do I even know? Who are the agents? What are the timescales? And what are the hypotheses that would help me to mark out the kind of research agenda? That is not a small task and can occupy, a lot of deep research and domain thinking. But I think it's really important to do at the outset to try and ensure that you're tackling, if you're going to put a lot of effort into something, we're tackling the right problems and the right parts of the system, or we're designing things with the right approach. Following that work, most of what happens next for the social science researcher, at least someone who's quantitative, is some kind of measurement, whether that's to discover and learn aspects about the system to inform theoretical concepts, or whether that's actually to test theoretical hypotheses and kind of implications that come from your conceptual theory. You're going to need to have some sort of material to test that with. I would say there's probably 3 generally ways of doing that. So kind of the more control to the less control. The more control is kind of, we go into the lab, very familiar for the psychologists around. For economists, this involves both lab-based and field or quasi-field or even natural experiments to some extent, but that comes in down here. We run surveys, we do interviews. Some people also do what I think is a really important job, and that's a big part of my background, is agent-based modelling. For me, complex systems, complex adaptive systems, if you follow in the kind of trajectory of like Santa Fe Institute and so on, which I do, agent-based modelling is usually the obvious choice and the joined at the hip choice for methodological advance when it comes to a complex system. If you don't have an agent-based model which can handle the, as Scott Page would call, the level of interplay between the agents in the system, usually because of some networked, non-linear interactions, then you probably aren't either modelling enough of the system or you've contracted back to some mean field approximation with a theoretical model. And you won't have anything like the emergent, self-organising, non-linear kind of behaviour that this system really exhibits in the real world. And if your whole purpose is try to capture structural change or, social change of a kind which is actually from like one very self-reinforcing, seemingly forever equilibrium, and then everyone wakes up next week in some absolute dream world, which was always thought was impossible from the perspective of last week. You're dealing with a non-linear system. That's not a linear transition. That has got to be some sort of non-linear, rapidly expanding kind of connectivity avalanche style, breakthrough moment to a different equilibrium. And if your model can't do that, it doesn't have that as a capability because of its linear constraints, you're trying to, model the processes of clay with, water or something. You just don't have the right material to get the properties that are actually part of the system. So I'm a strong advocate for agent-based modelling, and I'll talk a little bit about that later. Most of economics and econometrics hangs out in these kind of grade-in areas, not for the moment ABMs. So either surveys, national surveys, subnational surveys, industry surveys, consumer confidence surveys, etc. Traditional service sources of data. So, economic data from statistical agencies at the national or disaggregated level. Every country has their own bureau basically for producing these statistics, and it's the work of the economics or econometrician to go and gather those statistics. They usually come to you as a CSV or a table or an Excel sheet. They're already in structured form. You coerce them through filtering and so on into your software and then run your regression models. Or you've got really nice controllable data coming off your experiments because that's how you set it up. What is not being done a lot yet, and there's only sort of the beginnings of it, is what we've mainly been talking about here, which is everything else, all these sort of so-called ecological settings where I've got, real life and everything going on and data being produced through administrative or business or behavioural or government action or just people living their lives, touching digital techniques and all these moments. And we've got this incredible amount of usually unstructured data, which is now possibly open to us through techniques like we've been discussing the last couple of days. So putting that together, I think it's sort of an exciting time, because if previously you were trying to tackle this sort of stuff and you had a kind of complex system and you were really thinking about large-scale change, and most of your lens, your kind of glasses that you could see that large-scale change was traditional kind of ways of learning about it, usually controlled by authorities or, those in positions of power. And it was actually really quite difficult to get it, like stuff happening in real life, in the cut and thrust of, the interactions of people and their communities and their networks. now is a time when we can actually scale up this kind of access if we're good with our tools and we are smart about how to use them. So I think it's a positive story, hopefully, but that's the kind of roadmap for what I'm thinking about in terms of this afternoon's conversation. So the starting point, as I said, is like, what's the system? Here's just a few examples of systems thinking from different worlds. So one that just came out from the Lowy Institute from Lydia Cahill and co-authors. I saw this first when she presented the prototype at a conference on democratic resilience a few weeks ago in Melbourne. It's just been released this last week at this website, and you can tap in and explore different aspects. And what this is on the website you'll see, is a whole set of factors which lead to undermining and decay of the kind of legitimacy and health and resilience of a democratic system. It's not that every one of these arrows has been causally identified and we know exactly that these are the connections. That's sort of a program of work to be done. But it's conceptually how different subfields have thought about different aspects of the democratic resilience story. And it's putting it all into one page so that at least we have some sort of roadmap for research focus and warning signs and signals and how things interrelate. And it's like, I think, a really cool thought process to actually think it through and make people aware of democratic kind of decay is not one thing on one button, but often it's a multitude of buttons being pressed at the same time and often with cascading implications. Yeah, there's one country in the world with one leader who basically, I feel like, is using this as a bingo card and a lot of hits, okay? Which is really worrying. That was not why this was built, but like, that's where we're at. Okay, this is another one. This is a piece of work that I'm working with at the moment with some colleagues in Australia. And it's the interaction between democratic resilience and disaster resilience. If you've spent time thinking about democracy, you realise that, there are moments when well-governed democratic countries suspend human rights and freedoms for reasons that they argue and are given the powers of in their constitution because we all agree, fair enough. So natural disasters, war, conflict, etc. are one of those things. In Australia, as you might know, I come from Melbourne, kind of the most locked down city on the planet during the COVID-19 pandemic. The legacy of that period where, we were willfully sitting in our homes and wearing our masks and nervous about the impact of COVID-19 for elderly and vulnerable communities in Melbourne. But I wasn't living just, about 800 metres away or about 2 k's away in a housing commission building, a place which is basically government housing, where they locked down the entire building and no one was allowed to come and go. That community, researchers have shown, is still reeling with the implications. Their distrust of government from now on is like absolutely massive. And there is argument to say that it was the powers and the way of going about that moment of disaster, crisis handling, which has sown the seeds for a weakening of democratic resilience in some areas in Victorian and Australian communities. As I speak, there's currently, for example, a self-proclaimed sovereign citizen at large in the Victorian bush, having killed 2 policemen about 8 days ago. And that's really worrying. So there's now much more attention being paid to people who are stepping away from traditional forms of law enforcement and proclaiming themselves to be aside from our traditional norms and institutions in Australian society. And many people still point back to the way that the Australian government has perhaps at local and other levels made some alienating steps in handling these things. Now, I generally think Australia is really well governed. These are pockets of resistance or problems that occur, but there's certainly a connection between the way that we handle and think about natural disasters and emergencies and how governments wield those extraordinary powers. Are they actually kind of looking to strengthen through inclusive, fair, and sort of strengthening activities during those moments of crisis to sow the seeds for a strengthened democracy and therefore strengthened resilience in the future? Or are they seen to be, or actually abusing those moments, dividing, separating, and sowing the seeds of a weakened democracy and perhaps weakened disaster resilience in the future. So again, putting them all on one diagram, this is sort of the paper we're writing, is to try and show people and show governments in particular that this moment is a particularly important moment when it comes to your handling of a future democratic resilience, because of the way that environmental and other disasters impact that. And then another example here is another piece of work. This is with Emma Thomas and Winifred and Ryan and others, where we have this agent-based model which we call DimeSim, which is based around Thomas, Emma and Winifred's work to do with the DIME model, which is a psychologically founded approach to collective action. And it's really nice for us from an agent-based modelling community to work on this kind of model, because they've got all this brilliant data from experiments they've done with estimates where we can actually put into our agent-based model, rather than looking out the window and making a parameter and sort of thinking of a range and testing it. We actually have grounded values for these from their experiments. So we actually are touching reality with this model rather than scenarios that might be. And the idea is that we have this sort of integrated multi-scalar, like at multiple levels, happening in one model. So there's an authority signal at this level operating down into the individual responses, and responses for the individuals are either that their movement is succeeding or failing. If it's failing, then under some treatments, we give the individuals an opportunity to reframe that as success. So a sort of self-reflection based on their psychological variables. Or in another treatment, we allow them to do this collective reframing as well, which means in a network of individuals, they can kind of be seen to chat or converse, and they might reframe it as success as well. Depending on how much opportunity they're given for those and they're parameterized, we end up with looking at the overrun, outrun, and then the community takes another action, and we get back to listening for the next authority signal. The reason why I show you this is that in systems thinking and complex adaptive systems, typically what's important is not only the overall bird's eye view of the system, but the scales at which it's occurring. So we've got here an aggregate kind of country level, national government scale, down to an individual scale. And it's the interplay between the two scales which is important. So the kind of collective, individual and government authority. And systems thinking is a good way of uncovering that, and can lead into good questions about, okay, so how can we get at some of the dynamics happening in networks, or thinking about the individual experience, and how does that then relate back up to the government and then back again? Agent-based modelling can handle all that. But that's sort of a good starting point for sketching this out, is definitely the starting point to writing a good agent-based model. So what is the system? What are the boundaries? What's the flows? What's the states? What kind of things am I going to be tracking? Just an example, in this model, what we want to track is not only the kind of actions of the individuals, what kind of decisions they're going to make from a protest perspective, but also the DIME states, the psychological states. Both of those are going to be important for characterizing the system. And different systems will have different states that you want to be tracking at the individual or the collective level. And that's the sort of starting point, I think, for systems analysis. Now, when we talk about timescales, I'm really a student of knowing that slow-moving, infinitesimally changing things in a nonlinear dynamical system can eventually have rapid, massive, whole of system impacts. At least it's true in the equations, and I know from experience and history that sometimes it seems to be true in real life. And one of the, touchstone papers for many of us who work in complex adaptive systems and agent-based modelling is Lindgren's paper, Lindgren and Nordhalle in 1994. I first read this in one of the SFI's books about artificial life, and I was just enthralled. This diagram in particular. So the model is one where you've got a bunch of agents playing this really simple, they've endowed with this kind of lookup game, which is what do I play in terms of a prisoner's dilemma type setup, with a strategy that's encoded from a lookup table about what you've played recently and what I'm going to play. And different strategies can be more or less complex based on how much kind of state they can deal with in memory to play the next play. And so what you end up with is an evolutionary system, which means that the strategies that were more successful in the previous period, the fitter ones, end up having a more proportionate reproduction in the future period. You get this incredible kind of like long-run, epoch-forming dynamics. Not every run, but in some runs you certainly can. And it shows you these different phases. For example, you've got these periods where it seems completely chaotic. No one strategy is leading or, able to get the ascendancy, constantly being torn down, massive uproar all the time. Then you get moments of incredible stasis. And remember, like this is 30,000 periods. A period here could be a year. It's like 30,000 years of, one stable government. And for everyone thinks, that's it. Like, that's our life. There is no hope. There's nothing different other than being ruled by, 0001, whoever that is, okay? And then suddenly, look, on one, in 1 year, it crashes down and we get replaced for a time by 1001. And probably for all these people, up until even this moment before, everything looked kind of the same. But there was this tiny, tiny movement of one strategy that was just getting a little bit more prevalent and then suddenly got the ascendancy and the whole system changed. That's non-linear system dynamics. And this model and its kind of outworking is a really powerful representation that, it's every update, it's doing the same mechanistic changes, and yet you can get this variety of system dynamics coming out of it. And I think it's a good reminder that timescales are really important to thinking about large-scale social change, and that we shouldn't be despondent when it's like nothing seems to be happening. But we should also not lose it when lots of things seem to be happening and that no equilibrium can be established. We have probably got, we've got different things going on at different timescales, and we need to moderate our measurements and our thinking and our experiments and so on to take account of that. So remember Lindgren, it's a great paper. Okay, so states, as I said before, what should be tracked? And I foreshadowed that in, for example, this agent-based model. So here we're, as I said, trying to understand mobilization with a psychologically founded and grounded state model. The two things we wanted to track was not only what kind of actions these individuals were going to be taking, so whether they're going to be active or latent in their protest activity, or whether they're going to be innovative, conventional, or radical. And that's one thing that most people focus on, but we also wanted to focus on these dime variables to see how these are varying along with the action states. For us, that was kind of the encapsulation of the system at any one time, those two panels, if you like. And the results here, this is kind of low failure, which means that it's the responsive authority. So the probability that the authority rejects the appeals of the people is quite low. So they've been quite successful. And we would characterize this as both psychologically and in action as somewhat of a, normal, healthy-ish, protesting democratic environment. But what we were able to show is that if you have a high failure rate and there isn't the opportunity for individual or collective reframing, you can actually end up with a system or a population which is almost entirely built of latent radicals. So they are not out there active at the moment, but they are basically ready to burn, and they're ready to burn with radical techniques. We wonder if this is the precursor to something like a Tahrir Square uprising and so on. And we can see that these individuals have got similar high levels of disidentification and moralization and lower levels of innovation and energization, which is like, really helpful for us to characterize the system. But every system's different, and you need to be thinking about which aspects are kind of, the important ones to be tracking as you come through. The other thing I'd just say for AVMs is that what's usually really helpful, and what has happened in this project, is the ability to turn on and off different modules. That's something that when you're designing code or experiments, it's really nice to be able to show what the influence of different modules are. Reviewers love to see that, and it's helpful for us to isolate the impacts of one or other factor, and that's a lot of what the work is. Okay. We don't have access always to artificial agents, so we're going to have to work most times with ecological data. I already showed you working with, whether it's Hansard or News, so I'm not going to spend too much time thinking about that, and I'll move on to some of our other sources of information. So social media is like a really common, when people think of like ecological data, often they think of social media. And the point I wanted to draw kind of draw attention to is that there's a growing opportunity and risk that social media can be used to infer attributes of individuals which they may not necessarily be willing to divulge explicitly. And the first, I think, example of this was the Yao paper in PNAS, which led, I guess, to the Big Five predictions that led to the Cambridge Analytica cases. You'll remember that they only had to observe about 300 likes and then have a better prediction for your Big Five personality than your spouse. And that, I think, was like, most people were like, you know, that's like crazy, because most people, when they sign up to Facebook or Instagram or whatever, there's a purpose description and they talk about the data privacy, but no one at the moment says we will start inferring, you know, hidden attributes about you, including your psychological states. Like, it's just not really covered or required by law at the moment, this inferred attributes question. Our research question in this paper, which is on Reddit, is we were exploiting the fact that in Reddit, there is this political compass memes subreddit where people can flare, which means to kind of let be known, their political ideation on a two-dimensional scale. If you believe that to be true, and there's reasons why that may be true or maybe a little not, if you believe that to be true, what we then did was to build a machine learning models that would infer this ideological stance with only observing some digital footprints of your interactions with Reddit, which for us meant both the text of the comments you made, but also which subreddits you were part of. To our astonishment, the text was not actually that informative beyond and we threw, like, you know, every embedding and vector and transformer model at the problem. It's actually the text carried no more information that was already revealed by what subreddits you're actually part of, which was just a 0-1. If you'd ever been part of this subreddit, well, didn't matter if you commented a lot or not very much. We could just see the pattern of your subreddit activity was enough for a machine learning model to infer your political ideology. And this is, by the way, excluding a whole lot of political subreddits. So these are like stuff about cats and TV shows and whatever. Turns out they're really indicative of your political ideology. You might not be surprised, but again, just pointing out that when it comes to, you know, if you want to try and work with ecological data and infer things that maybe are important for political change or other factors, you don't necessarily need to be thinking to yourself, you know, where are people making known their political ideology? Sometimes you can actually infer these things from other behaviours. I'll talk later about the kind of safeties and risks around that. And just as an aside, one of the sub-studies that we did in the paper is to repeat the Yao approach by saying, well, how many subreddits do I have to observe? So I've got everyone in the can who had at least 200 subreddits available, and our main model was able to observe all of those 200 and build an inference for their political ideology. And the accuracy on the test set is, you know, over 0.8. If I have a 0R model, which is the dummy classifier we talked about earlier, so just using the major class with the inference class, I do worse when I've only got 10 randomly chosen from those 200 to infer from. But as soon as I've got 25, I start doing better than 0. By 50, I'm doing substantially better. So I actually don't need to observe your full history. I just need to have some view of your subreddit histories, and I'm already doing pretty well at starting to infer your political ideology. So it's actually really quite informative, which I guess, on the one hand, let's stick away from the safety thing for now, is like really positive for this question of social change measurement and tracking, because it tells me that digital footprints being left by individuals with their touchstone with all these things is actually really interesting and useful information for social research about, you know, some things like political ideation and other factors which could be important. There is a dark side to this, which we'll get to, but that's like, you know, these are techniques and capabilities that are sitting there ready to think about and use. Okay, and then moving on the social media thing, I've referenced this a couple of times. There's another project, this is the one with Emma and Cass, which is where we're trying to understand in a social psychology model the QAnon community. And you can see here, I guess I have kind of 2 points. One is that it's possible to use LLMs for direct labeling using a fairly complex labeling strategy. So this is the human labeling schematic, which first we ask, is it supporting or not for the QAnon movement? If it's opposing, then we ask it, we need an irony or sarcasm question. If it's supporting, then we're going to say, well, is it exhibiting this tweet social identification? Is it talking about carrying out harm? Is it invoking collective action? If it is invoking collective action, is it traditional tactics or social media activism? If it is about social identification, then we can put it into different groups. We've actually dropped this for the moment for psychological reasons, but you can see it's a fairly complex kind of labeling task. And what we do is we then take that and put it into, and you can see here we talked earlier about my extended prompt for populism, and asked the question, could we have examples? This is actually a labeling guide, which is the prompt, and it's much longer than this, right? This is just for one question, the first question. And so what we do in the model is we don't ask all of this at once. I apply to the tweet the first labeling guide, get the answer, based on the answer, then I move on to the next one. And it's got its own labeling guide for each of these junction points. And that's a conditional labeling pathway that we have within the modeling environment. So I guess my first point is that you might have thought that traditionally a social change research project with social media would be dealing with relatively surface level labels or something like that. I want to suggest to you that current models are pretty capable with really quite involved, fine-grained labeling tasks. And it's better, as we discussed earlier, to break this up into subtasks rather than asking it to do everything at once. And notice that sometimes I will never even enter these areas if I'm off topic or unclear, which cuts down on my costs anyway. Okay. So the first point is that you can do quite elaborate things with labeling these days, and even in relevant social psychology settings. But my second point is the one I want to make for us this afternoon, which is I think that this project is a good example of what I think is the sort of future or the way to approach this practically. So practically, I'm a complex system computational kind of guy, a bit of a Swiss Army knife around different techniques. And I really like working on problems where I think it's going to make some sort of social good, put it that way. But I'm not someone who can run I'm not typically running social psychology estimation experiments, lab-based or others, to try and estimate, causal factors in a social psychology model. But Emma and Cass are. And what I think is needed in this sort of research space is what I keep referring to as this bilingual capability. What I mean is that you need these deep kind of domain experts, because what we did in this paper is we actually had them, Cass and some others, labelled 1,000 tweets. We used a stratified sampling technique because we've got 100,000 of these. So we made sure that we've got some representative material from the tail cases in our 1,000. We defined a dev set, so 100 of those that we're going to work with as we create our prompting scheme and test that. We then iterate over the first 30 or 100 of those. And what I'm doing is constantly, I'm testing against a battery of models. I'm refining those prompts, taking the answers back to Cass, asking for her domain expertise. She's writing a report back to say, basically, this is how the language model went. This is what I'm seeing. Here's systematic failures or wins. These are failure modes. This is how I think we need to change the prompt. I do that again. We iterate and back and forth. I think it's been a really, and continues to be a really fruitful relationship, because we both sort of have enough in common in terms of she understands what's kind of capable computationally, but is really strong on, the social psychology models. I understand pretty well what's going on and what I can do here, but I really understand and want to work with these social psychology projects. And that, I think, is going to be crucial to the validity and the kind of accuracy of our work. We've just run the 900 on the test set, so we're now going to be able to evaluate an ensemble of I've got a whole bunch of different models who I can run against, and we can compare to the human labeled 900, and then we'll be able to select our best approach, or it might be an ensemble of approaches, which we discussed already this morning, and then we'll run that on the 100,000 tweets. I feel like I could have sat there in my lab and, somehow got the QAnon 100,000 data set land in my pocket, and I'd probably do something with it. but I don't think there'd be anything like as kind of richly high quality in terms of the research question we're able to tackle if I hadn't been working with these guys. And so I guess it's my my suggestion, my example to say, like, I think the future of this sort of work is team-based, and you want to be able to build that capability with differential capabilities across the team. And that means, yes, the team might get bigger, and yes, that means that you need to kind of find a common language. But the key is that there's some bilingual nature to everyone on the team. Everyone's got some reasonable exposure to each other's sort of way of thinking and approaches, so that we've got a common language and dialect to kind of progress this. I have been involved in projects before where if there is not enough overlap, it's actually a risk on both sides. So what I find is that if someone is not really across the computational techniques enough, too much power comes onto my side in terms of making decisions. And I find often the domain expert doesn't really know what they want. And I'm having to make decisions which I feel like, probably should be more on the foot of both of us jointly, scientific decisions, whereas I'm just having to make them because it's kind of, I'm like a black box to them. It's a risk. So I feel awkward about that. And it's a risk for them because then when they receive my results, they have no idea really what's good. They're like, great, okay, what does it mean? And I'm like, well, I tried to explain, and and it feels like it's a bit doomed because there's barely any overlap, and we don't have a common basis from which we can kind of trust each other and also scrutinize each other to a certain extent what's going on. So when I think one of the kind of questions coming into this, strain of workshops was how to select or think about, researchers to work with. My big vote is to try to find some bilingualness in each party. And a good question would be from the computational, to a computational person, what do you think we're trying to achieve? Or could you talk back and explain what kind of statistical models we're thinking of using? Like, do they understand that? Because some computational scientists have only ever worked on computer science problems and papers, which is a horse race of my method versus other methods. That's not actually working with real data or real estimation models that everyone in social sciences work with. It's, by my experience, it's fundamentally different. And often pure computer science people don't understand the social science tool set. On the other hand, like from this side, I would be asking, what do you know of, F1 scores or accuracy, or what's a good model, or, have you got any exposure to thinking about, machine learning or something like that? Because I don't want them to overly depend on me and my expertise, because that will not be a successful collaboration. Okay, so that was my little vote for bilingualism. But there's beyond social media. So I just want to go and give you some other thoughts. This sort of idea of like ecological data is literally everywhere. It's just creativity between us and like doing something with it. So Google is used like a lot by a lot of people to find stuff. But the challenge with Google, if you've ever looked at Google Trends, is that it's all a relative measure. They convert everything into an index, and the most information that has been, the most searches that have been done in a particular time period is given an index number 100, and everything's relative to that. But you never know the actual volumes. Why is that important? Because it means if I'm trying to compare between the volume of search for hairbrushes versus chocolate cake, everything's normalized at this peak of 100, and I can't actually compare on levels which one had more interest or not. It's all level internal. So what do you do with that? Well, what we've done before, and this is a paper which was a really good honours student that I had yet to get out there, but we're working on it, is the question was, how can we get at something like religiosity? So, how much is religiousness important to different cultures and groups around the world? An interesting question for a lot of social science researchers. And there were some traditional approaches to this, and one way that you can do it with Google Trends is that you need to sort of normalize or use as a ratio your thing that you're focusing on to some sort of baseline. So imagine that if I could find some banal Google search terms, and I can try to net out the amount of people who are kind of moving on and off Google at different times by looking at them. And so I turn everything to a ratio to those baselines. I'm using them almost like a a baseline from which I can, convert my my measure of religiosity, whatever it is, I convert it to an index or a ratio compared to these baseline approaches. The reason I want to do that is because they all going to have the time series and sequence of people more or less on Google and volumes on Google and everything like that, so that it gives me an actual way of converting this into some sort of informational value. So what we did in this paper is we actually were able to identify a bunch of baseline topics. So here they are: hairstyle, life, earth, and computer. Because you need something that's really universal across all cultures. You need something that's not dominant and therefore is similar scale to religious topics, and something that's really stable over time. So for example, love is not a good candidate because you can see it's got declining relative research interest as Google over the search period, okay? You want something that's kind of effectively stationary over the period to operate as your baseline measure. When you do that, and we have a whole bunch of Google search terms which lay on top of that, which I'll show you in a moment, we find that we can actually relatively accurately, so here's mean average square error or root mean square error, we can actually fairly accurately, within sort of 10%, predict the religiosity within a country or a sub-region. We do that with using leave one out approach, because we know from World Values Survey and other surveys what the religiosity is from surveys, and we only take the survey results in countries where we think people are unlikely to self-censor because of an authoritarian background. That basically converts Google from a Google search thing into like a religiosity measure at global scale with fairly good accuracy. And it becomes really interesting when you apply it to countries, for example, the gap between their stated religiosity and then what you can infer with Google search trends. For example, Turkey was the standout for us, where it seems more religious in survey-based stuff, but our measures saw it as far less religious than it seemed to be. And just as an aside, because we've been talking about methods, you might ask to me, like, well, how did you decide on the religious search terms to use as your kind of above line thing? And the answer was, I actually went to an online repository of Library of World Religions. I got 458 docs, which were the beliefs and the ritual worship kind of language about them. I put them through a standard kind of pipeline for NLP, getting rid of stop words and everything, converted them into word embeddings, so using Word2Vec. So I've got all of these words from all of this document. I actually pulled the whole lot, I don't care about it, put it into Word2Vec, and then I clustered all of those words into different clusters, 20 clusters in high D space, and I got the 20 nearest words, because what I'm trying to do is find a really hands-off, agnostic, hey, it was the data that drove it, kind of way of coming up with religion words that I can put into my religiosity Google search index. And so what I ended up with is 59 Google search topics, which match close to all of these clusters in high D space in the word cloud. So just another one of those, like, you know, hey, don't forget word embeddings, they're still useful. This is actually a word embeddings problem, because I really wanted to focus on, I wanted to get words at the end, not sentences. And I wanted to find it from a semantic space based on all of the words used in this traditional religions book. So yeah, you can do that with Google Trends. So my point about Google Trends is even search can help you with like interesting social terms. And there's no reason why we went for religiosity, but there's no reason why you couldn't use a similar pipeline for whatever, you know, is of interest for a trends analysis. The only caveat to that is, of course, Google is not highly used in some countries, and in fact is banned in places like China. Okay, so let me have the conversation about safety. It's all well and good to infer religion, politics, and psychological states from digital footprints on social media, and they're all relevant and interesting for, you know, social change measurement and discovery. But we know from history that, you know, inferring things from Facebook can lead to targeted campaigns which tip elections and change kind of the course of history. I've just shown you that I can pretty accurately infer political ideology from digital footprints data on Reddit. Who's going to use that information next? Okay, so what do you do if you're moving into this space? I think you've got to think about the safety implications of publishing potentially what I'll call dual-use research insights. Yeah, my view is that you should think about it. You should find some reference kind of governance framework around what you're doing and to make sure it's not you alone that making the decision. But I think there's basically two ways to go. One of them is to not publish, and because you think that your method or mechanism, if used in this other purpose, could unduly put at risk or harm people, and that may be the right decision for certain applications. The other bucket is that you decide to publish, and the reasoning for that, I think, has to be something around, we want to make people aware that this is possible so that policy, regulation, and platforms can potentially protect against it. Or at least that the people who hold the minority, religious, or other perspective realise that their interactions on this platform or that platform is a risk to them, and they need to act appropriately, whether that's with anonymity in their interactions or being more careful, etc. My fear is if you know that it's possible and you don't publish it, then it's highly likely someone will discover it anyway, and then it's a silent fail because community and the general public don't know yet that that's a problem. And you know it's a problem, but you haven't alerted the world to it being a problem. There is a sort of a third path, which is that you alert the people who specifically should need to know, but without publishing broadly. So you try to limit the fact that a bad actor would misuse your technology but try to emphasise the protective technique of getting it to the right people. So, for example, a discussion we were having earlier, the people who do cybersecurity risk analysis for operating systems like Mac or iPhone or, on Google or Android or whatever, research labs will often not publish publicly the exploit that is an attack on the system, but will actually send it directly to the operating system provider so that they change it and issue a patch, which is that sort of third way of like trying to communicate it to the right people to let them know about the risk and get the change made. But I do think it's like a real concern. And if you're going to go and wade into questions of, protected or private inference at large, then it's really important that we are wide-eyed about the implications of those research findings, because I hope that our work is not leading to whatever the next scandal or ad targeting campaign might be in the future. I hope that people would go, okay, that is really important for us to know about, and it might change behaviour or at least make us aware of it, so that we can look out for it and be more attuned to it from a regulatory or civic community approach. Okay, so let me use the last little bit of time to talk about maybe something a bit more ambitious. So moving from more traditional kind of stuff at the top here, where most people have probably worked for most of our lives, through to ecological alternative data, which is now becoming so much more available through modern techniques. The last one, I think, is like the question about maybe the data that you really would love to have doesn't exist, and you need to build your own platform. That is like a big step to make, to build a data generating platform, and it comes with a bunch of different considerations. So let me talk about those, then I'll talk about some design thinking, and then I'll share some experiences from the observatory that we built. First, you need to think about the initial funding, obviously. Who's going to fund it? What are their expectations and for how long? It is not easy sometimes to convince someone about something that doesn't exist yet, about its value. So often you need to point to other platforms or things that use like, we're going to be the this of that, so that you can get them across the line. Sometimes it's like, I don't know, we're going to be the, the weather station for, right-wing extremism in Europe or whatever. And like, oh, okay. Sometimes you got to cut through to the funder to like make them aware of what you're trying to do. So that's good, but then you need to be thinking, okay, so who has the technical needs or knowledge to set it up, and Can I find those right people? Can I keep them on my thing for the first period? Obviously, governance is going to be important. Often this is missed early on, and you sort of only walk your way into governance considerations later. But it's important that whether it's partners that you're getting funding from or will get funding from, or users that you will hope to get involved, or data users downstream, have a sense that your tool is trustworthy and operating in a right way. In my opinion, universities are the place to do this. Universities still, touch wood, have a privileged place in society, as I think we stand a little bit apart as, by definition, here for the good of all. By definition, I feel like universities, when I talk to students, when they walk onto the campus, they should feel like it's a more inclusive, more free, more equitable, more kind of open-minded, environmentally conscious place. And it's a little taste of a future. And I want them to know that when they come onto the campus. I hope that's what it feels like. And when the community looks to the university, I hope that they see a beacon of truth and uncompromising truth, a place that, uses the scientific and other methods to uncover fact from folly and to, discover new knowledge to use for the benefit of all. That is a really privileged location in the world. And I don't think universities necessarily recognise that opportunity. When it comes to the Observatory, for example, I'll talk about it in a moment, we were told early on, like, surely the government organisation X already does this, or why don't you start up a not-for-profit and do it from that? Or wouldn't this become like a commercial thing? Why don't you do that? And we were very resolute, and we still are to say, no, this is like really important that our footprint is at a university, because there is going to be users of our data and abusers of our data, people who want to reject what we've found, it'll be harder for them to do that if we say, well, no, we're a university. That's the starting position. We don't have a political agenda. We are a scientific community, and we're here to measure things with trusted methods and techniques. We don't have another agenda going on. So it's my vote to say universities, I think, are the right place to build platforms, and we probably don't do it often enough. That I should have a little box here about incentives, but we'll probably get to that later. This is a real non-traditional kind of research activity, but I wish that there was more of it going on. That said, we do need some sort of governance. Most universities have got some sort of ethical statement or way of governing choices made by academics and resourcing, but it may not be enough, and you may actually need to call on some other trusted friends with requisite capabilities to help us at Little Government School. Okay, other questions you've got to answer. Who is the data for? This is a big question when it comes to measurement at a university, particularly in an academic and a research sense. We are by nature, if you're quantitative, very protective of data. And we don't want to let anyone have access to the data until we've done our publishing from it. And even then, we may not want to give it out. That's an economics perspective. Thankfully, there are perspectives which are changing, which is actually it needs to be open data from the beginning. But there is still reasons why your platform may not want to make it wholly open right off the bat. And that's because there are actors who might misuse your data and do things with it that are really not what you intended. And so I think there is a good wisdom in, at least for the early stages of data generating platforms, thinking about a bit more carefully about when and how to release that information and to make it available. You may get requests from journalists, from corporations, from other research teams, government. There's all sorts of, maybe even the military. There's all sorts of people who might start asking you questions, and you need to sort of have a bit of a response for that. That kind of leads into partnerships. So who are you willing to partner with? There can be downstream implications. So if you partner first with defence, that may have implications for your next partnership with, a human rights body or something like that. And often these technologies, when we're talking about large-scale social kind of measurement platforms, often a variety of people get interested, and we need to sort of think about what our approach is. And finally, the big one is sustainability. You can get really excited for your first funding round, and then at some point you realise, hang on, we've got 6 months of runway left to pay for our infrastructure and our people. What happens next? And that is a living crisis if you've built something precious like a data generating platform. I mean, at the Observatory, we have now over 5 years of data, and that's actually become now a valuable thing to be able to say. Like if someone's about to turn off the lights, to say, by the way, you're going to end 5 years of continuous research measurement at global scale. Like, do you really want to press the button? Like, it's not like, let's just calm down and talk about it before we, stop this going. So there's some early considerations when thinking about building a platform. I want to then make a bit of a sidestep conversation about like building the platform, which is a big data point. Classical data science, I'm going to call, typically is where we build some sort of data generating activity with a specific research question in mind. So with my students in class, I talk about the Mawson trip to Antarctica over a century ago. These guys went on a scientific mission to the South Magnetic Pole. You may know the story. Amundsen and was the other guy, died in basically vitamin A poisoning from eating dogs. One of them fell in a crevasse. And Mawson had to spend another winter down in Antarctica and brought back eventually all these rock samples and meticulous maps and so on, but with a whole bunch of scientific questions driving that data generating activity. I would call that classical data science. We get funding, we have a research project, we say we're going to collect this data because it's going to answer this research question. It's a really tight connection between a research question, the data, and the write-up. That is classical data science, and it's great. But I want to suggest to you that there's a different conceptualization, which is big data science. And when you build a platform, I think it's worth thinking about making it a big data platform. What does a big data platform mean? So I'm going to take the definition from Maya Schoenenberger, which is less about the size or scale of the data, which is what some people focus on, but more about its usefulness for subsequent research questions. So take these two photos. Imagine that, I was going down to Antarctica. I'd set up a penguin, measurement facility that was going to take a photo every time there was movement in front of the camera. And I got this camera back in the lab, this photo back in the lab. I'd set it up as a classical camera because it was just going to collect, I wanted to count the number of penguins of this species coming by. And I'm doing this, image counting, and then this guy crops up in the image. I'm like, hang on a minute. That's like a beat that I've never actually seen before. I wonder if it's a new species. But unfortunately, my camera had a focal length that was only focused on the penguins that are a little further away because that's where I thought they would be. I've made a classical data science faux pas. I've thought that I had one research question when I took the photo, but another research question has turned up subsequently. And unfortunately, my data collection process is not able to answer the question because it's not in resolution. If I'd set this up as a big data research data generating process, I would have used this camera, the Litro Ilium, which actually, when it takes a photo at every single focal length possible in front of it. So it's lots more data, and a lot of it is like, I don't know what to do with it, because most of the time there's one penguin, and like I've got a blurry picture of one penguin or a sharp picture of one penguin, but occasionally I get a really sharp picture of this one. And now I don't need to go back and recollect or get funding again, go back to Antarctica, collect more classical research data and see if this exists. I'm now actually able to ask an entirely new research question of the data because it was a big data question, a big data generating process. So my suggestion when we collect, if we're going to go to the length of setting up a platform, think about setting it up so that it collects basically the universe of data, not a sample, if possible. It's passive in the sense that we get as much human behavior without them knowing that, it's happening. And it's consistent so that a measurement taken day one of your measurement apparatus can be compared exactly to one in 15 years' time. Now that last one's a big call because it means you've got to like commit to a certain way of measuring and a certain decision making that is going to stand the test of time. That's not easy to do, and of course we're allowed to revise, but you want to have something like that. It's like I missed my reference for Schoenberger. So our platform at the Monash IP Observatory is just an example, a data generating platform. Today we do about 3 billion measurements a day. We have 400 million endpoints, and we have commercial cloud support across different continents. And we do what I call the science, the scale and science of pinging, which a ping just means asking a simple question, are you online? We do a large number of them every hour. and we have science because we have a particular sampling strategy for built-up agglomerations. In 90% of the world, we actually measure all the internet that's known to be there. So this is a light-based photo of our measurements globally. Now, we live down here, and most of this was set up on that laptop, you know, next to my daughter's bed, like while she went to sleep at night. Some people always ask us, you know, where's the observatory? You know, we'd love to take a photo of you in it. And I'm like, well, no, you know, you can't, because it's like me and a laptop in a bedroom or on a kitchen table. The point is that, like, with modern scaling infrastructure and cloud-based stuff, if you know how to roll, you can do something extraordinary, like kind of take global scale measurements if you've got some funding behind you and some capability. And we didn't know, I've got to say, like, we did not know. We started thinking we were building a social science measurement, you know, generator for internet times economic research. I had no idea how many applications it would have. And that is, I guess, the moral of whether you build a platform or not, is that it can be a kind of transformational experience in terms of not only research data generation, but kind of engagement and impact. Today, like, we're the data provider for the United Nations Human Rights Office. We've provided early in COVID, we had a call from one of the commissioners of the US Federal Communications Commission, who's now actually in charge of it under current president, so Brendan Carr. And I was, like, in my front bedroom at home giving Zoom call advice on, like, the state of the US internet during, like, COVID. He got the attention, like, we got his attention by tweeting out about, like, you know, the resilience of different networks around the world that we could see during COVID. We've collaborated with the Washington Post, Wired, Reuters, The Economist, and so on and so forth. We had no kind of idea when we built this what kind of implications it would have, or that, you know, it would do this. But I think we thought that if we could pull it off, we were doing something kind of important. And we looked with anticipation to what kind of uses it would have in the future. Many people ask me, so how did it come about that, like, you know, The Economist or the Washington Post wanted to work with you? Or how did it come about that the UN, you know, knew about you, little you in Australia? To be honest, initially, like today, we have a really nice, like, reactive, you know, website with all, you know, 90 days of anomalies going up. People can interact with them, tweet, all sorts of stuff. I only put that into production, that quality website, like, I don't know, 6 weeks ago. For a lot of our life, we were basically a Twitter account where I would be putting up tweets of, like, observations and pictures and, like, you know, single page kind of images of things that we could see in the world. And what started was that we only have, like, I don't know, 1,400 followers or something on Twitter. But of that 1,400, we probably have 400, which are, like, you know, all of the digital journalists and cyber desks and, like, you know, some foreign affairs people. Like, it's a very high quality list of people, because what I came to realize is the kind of things that we could do with measuring the internet were not being done anywhere else. And somehow through those networks, people started finding us. The moral of my story here is that when you're trying to think about, if you build a data generating platform, then when you're ready for it, you know, being fairly good and savvy at getting the word out through social media and anticipating and being prepared to make those engagements can be a way to kind of grow the impact and influence of those sorts of things, and opens up opportunities that, you know, you probably wouldn't have thought of before. And certainly what's interesting to me is the engagement, for example, with the UN has driven our technology and our methods, because we've learned more about the problem they're trying to solve, and we've built answers or data generating pipelines which are solving their problem more accurately. And so it's actually an interplay between the end user, who we love, trying to use our data for human rights investigations, and us trying to serve that user better. And that kind of interplay is really vital to us. If we hadn't had that interaction, then I'm not sure that, you know, all these other things might have occurred. Of course, every single one of them means that we get another opportunity to interact and understand their problem. So where you can, if you've got one of these platforms and you're starting to build it, ideally early on, or even before you build it, you understand really well what end users, if you're going to have an end user scenario, would want from your platform. And one of the most affecting moments for me was actually before all of this, when we were just a Twitter account basically, and I had an activist, a human rights activist in Venezuela during, you might remember, Maduro blamed electricity failures on, was it US commandos turning off the electricity or something, because he didn't want to have the country realise that their electricity was just stuffed and they were all losing connection to internet and so on, and meat was going off in the freezers, and there was a massive problems. And an activist was on Twitter and reached out to me using messages or whatever and said, you have no idea how many people are using your information, because they were in a scenario where their government was not telling them the truth about the internet outages and the electricity failures across the country. And we were one of the few organisations who was at subnational level saying, these are all offline, this is online, and so on. And they were translating our tweets and putting it into text and sending it amongst those who are still at internet. And I was like, wow, this has really come a long way. Here I am with my laptop, and a Venezuelan is now telling me about the connections with what our data is doing. And I really understood that in this situation, what people in authoritarian or semi-authoritarian settings desire is they want someone to trust with information about their situation. And a lot of what I did in designing this new observatory is actually it's a mobile first site, although I'm showing you the desktop, for basically that activist to say, I know you want something that opens quickly on your phone, is easy to share, and will give you a sense of validation that what is happening to you or your friends, we see you. And that's kind of the motivation for what I was doing. I can't stress to you enough, that does not produce a research publication. It does not produce anything that is seen as valuable really in traditional university settings, to our shame. But I do know that in my experience, that's one of the most sort of important things that we can contribute to the world as an academic from our position as trusted people, to take our techniques and technologies to help people in their setting. And it's kind of worth doing if you can muster the funding and can think about the design. I would say that our story has been a successful one, and I will keep pushing for the continuation of the observatory for those reasons. Okay, so that kind of draws me to the end of my conceptual biggest sort of thinking about this design thing. Along the way, I've tried to sort of share, I guess, some thinking about systems, about teams, about funding, about safety, and also about the consideration of whether you actually build your own platform. Happy to answer questions, provide, there's a lot there that I probably scattered over, but that's been my experience. We aren't really doing exactly a big socials change kind of analysis ourselves, but a number of these things probably somehow apply in those settings. Good. That's me.
Thank you. That is a lot to take in. Thank you so much.
That's a good question. Yeah, so I was curious about what you mentioned in terms of the initial intention behind the observatory.
Yep.
You said it was internet and economics questions. Could you maybe explain a little bit more about that? How you got from those to all of this stuff? Now, what were the initial motivating questions?
So the initial thing that really took us in, it was so Paul Rashke in the class I work with, so Paul and I were supervisors for classes PhD. Let me see if I can still find it.
Oh.
So we originally, I don't know if they're going to show, oh yeah, excellent.
Okay.
That's what we saw, okay? And I think Paul, found it, and we looked at this, on a computer screen in our office. And we've been working at the time on this really massive data set, which was to do with internet activity, which was collected by University of Southern California as part of the US military PREDICT program. And what it was an engineering data set, but it wasn't connected to social science reality. There was no geographic locations in it. And so the big challenge was to then get a massive data set, which was geolocation of IP blocks through history, and find the right page from that to connect to the observation on a given date to where it was, to geolocate it, so that when we'd have a geolocated IP activity data set over like 8 years. That's class PhD. We saw that it's just so powerful. So the original papers from that activity led us to write this paper, which we tried to get published at Nature and PNS and all the others. See if I can download the chart too. And we did 3 things. We estimated global sleep. We looked at the diffusion of internet technology, of like the internet itself, and we looked at income and productivity across countries with the basis of the internet. And this was our attempt at our infrastructure in one diagram. And we've got over 1 trillion observations from the IP activity database, which we needed to connect to a geolocation database, 5.2 billion rows. And we needed to do a cross join. That cross join is impossible in any infrastructure. So that needed an index-based join, like a new technology. Class came up with that. And we were then able to get a final data set of 75 million rows based on urban agglomerations. This experience, right, was a humongous process, but it led us to be able to make so here's a global diffusion curve of the internet through IP space. So we estimated one curve as an ensemble, and then we've got offsets as for the diffusion curves for all these different countries. And so then you can actually see where each country is on its adoption curve and work out what's the number of IPs per person at saturation. Turns out it's about 3 per IP address. And we could tell where everyone was on their adoption curves and what the rate of change was. Like, no one had done anything like it before. And this is the one I kind of probably like the most, which is our sleep study, where we were able to train on the ATIS study and then do an estimate, a downscaled estimate at cities all over the US and the world for sleep. So you can see here, we're comparing, for example, the United States with Mexico. So these are the cities forming the distributions. North America versus Europe, Japan versus South Korea. And this is on the x-axis, is hours of sleep per night, inferred by training on cities in the US. And this is this little diagram here for me is the most interesting in the whole paper, which is this potential global convergence in sleep duration. No one has any idea. Sleep is there's people calling for more research on sleep. It's the most important thing ever. We've got a sleep crisis, digital devices, everything. But doing a global sleep survey, from your desktop, based on information from the internet, this all spoke to us the value of the imprint of human behaviour on the internet, meant that we could then measure and accumulate. So this sort of gives you some of the drivers. This is the juice of this is the air we were breathing at the time when we thought, hey, this is really valuable stuff. You can see lots of domains we could do research with this. On the other hand, or at the same time, we were getting really worried and frustrated with global events and geopolitics. So our first attempt at surveying and doing our own measurement. And the reason why we wanted to is because though this was a great experience, it was really painful. This geolocation thing for the historical IP dataset was extremely painful. We crashed one of Australia's largest clusters 3 times over trying to do this computation. And what it taught us is that we actually needed to get in control of our own data measurement and do it as a spatial spatial measurement operation from the get-go. So we had control over the data generating instrument with an idea of the kind of research questions we'd be asking, which we're all going to be joining to other spatial data and other, subnational and national data later. And that was sort of the academic-y research reason. But on the other hand, like when we stood up some infrastructure to start doing scanning, we just would do one country at a time, and then using a diff approach, we do the surrounding countries as well. The first one was like the Russian presidential election in 2018. Then we did the Turkish referendum. We just don't really like authoritarian guys, and we wanted to be able to bear witness. And we would set up these bespoke websites saying and send out like messages. I don't know who was listening, say, "Hi, by the way, we're currently measuring your internet space and the surrounding countries. So if anything happens in any of yours, we'll be able to measure it and we're going to publish it to this website." That's who we were. And what I then realized is that we were behind the eight ball when it came to protests or anything that arose without warning. It would take too long for us to stand up the infrastructure, and we would miss the beginning, and we wouldn't be able to do diff and diff because we didn't know what normal was. So we wouldn't know if there was an anomaly during a protest because we had no history for that place. So the only conclusion, and the only thing we're really good at, was cyclones, because you get about 4 days warning before landfall. So we could set up the infrastructure, get going, organise all the states of the US, because it's almost usually in the panhandle, and then we'd have a hurricane came through. We'd have all the measurements and shut down the infrastructure because it took 4 days for it to dissipate. But we're not really that's good and helpful, but I'm not a hurricane monitoring service. We're far more interested in protests and shutdowns and so on. And so, in February, I was like, let's turn it on for the whole world. What would that take? And we thought we would do it for 1 month. And once we started seeing the data come in, we were like, we can't turn it off. We have to keep going. And so that has been a continuation. So you asked the question, how did we start? We started with this research question around human behavior and its imprint on the internet and all the research questions we could do with it. But I think it has evolved to be much more we've taken on all these other this other mission around human rights and bearing witness in all these contexts. And to be honest, it's taken quite a lot of effort, that other stuff, and I don't regret it, but we've actually done a whole lot less of this. I can't point to the 15 papers we've done on the internet, in economics. We've got a whole bunch of ones that have started on, economic growth and diffs and internet and crypto and internet and environmental stuff and internet and hurricanes and internet and I've been pretty busy with getting the infrastructure going and maintained and the relationships and organising with the UN and all that other stuff. And that's just that's been life. Maybe we'll get to the papers later. Yep.
Does anyone have any questions online? Yes.
Oh, maybe I have another question. Simon, if it's okay for me to ask also, because of how, I suppose, unconventional the observatory is, I was also wondering how that shaped the kind of people that maybe are in your lab or on your team. Do you have people that are good at, writing blogs or who are good at organizing these meetings with the UN or that sort of thing? It's not just classic PhD student and PI dynamics, or is it all you, that has to wear all these different hats?
There's a bit of that. So, I do a lot of the external engagement, the data science, the platform maintenance, yeah, the website stuff. But, you know, Klaus, like, so every month, so in, you know, I've decided I'll do it when I get back to Melbourne, but every month we do a rollover about infrastructure. So a fleet comes on, a fleet dies, we inject 400 million new IP addresses because of the geolocation changes for many of them month to month. So Klaus does the first part, I do the second part, and together we make decisions, but someone had to take on the kind of public face, and I decided, you know, like I said, I'm happy to do that. So in the lab, we tend, for reasons of safety, not to have too many other hands touching the IP Observatory. You know, I know we're probably not making friends with a number of fairly nasty countries, and I'm okay with that. Like Melbourne, Australia is a good place to do that from. Probably better than everywhere except maybe New Zealand would be slightly better, a little bit further away. But yeah, that has implications. But you're right. So our lab is, I guess, characterised by a similar ethos. So all the projects that we do in the lab are often characterised by how do we tackle some power or freedom issue with social data science tools and, you know, and the technology we have. So yeah, what's cool to us is maybe not cool to every lab. But yeah, we've got a variety of capabilities, I guess. Most of the main platformy type stuff. In the early days of it was some of the website design and stuff was done by, we have a sort of like a lab engineer, if you like. Yeah, that's really not a traditional economics thing. So at the moment, like in the lab, I've got a full-time AI research lead is his title, and he's effectively an AI engineer. And I mean, he's a PhD in computer science, and his name's Lachlan. So he's the one who's built the assistant tool. So that's what we work on together. But that is completely a non-standard. Like building software like that is like, yes, like, I mean, we've been involved together in writing and doing research projects on NLP and things like it. And he was very involved in, you know, the PRF project and so on. But his role now is really building and maintaining enterprise level AI kit that we make in a lab and whatever the next thing will be. So we've benefited from a very supportive environment, I guess. So there's two things. One is I work in a business school. I had no idea at the time because I come from like my original degrees in like industrial chemistry and like political theory. And then I did a PhD in computational economics. And then I started teaching in undergrad economics. I had no idea at the time that actually business schools teach a lot of students, which means they actually make quite a lot of money. And their money generally is taxed and given to support across the university. What it does mean though, and what the business school, I guess, has really embraced in recent years, is they've come around or seen the opportunity to be a pretty active business school, not just one that I guess teaches undergraduate stuff, but also gets involved in executive education, all the things you would expect from a business school. It does, I mean, we've still got really very strong traditional economists in our economics department who are not businessy at all. But it does mean that in our leadership, there are people who are willing to take bets on more enterprising, you know, oh, you're going to build a, you know, whatever, like a global scale measurement apparatus, like, okay, here's some money to start it off. And to be honest, still the business school is our main partner. Like they still are the ones who keep the lights on at the IP Observatory. And it's not an insignificant amount of money every year with cloud infrastructure to do that. So I think that's an unusual setting for those two reasons. One, they've got a bit of money, which is not true of many people in academic work. You know, getting a £10,000 grant or something is like hard graft. And two, there's an entrepreneurial openness in a business school that may not exist. So because we are kind of now encouraged, and I'm part of engaging with, like, doing training with large corporations in Australia on AI and things like that, it's really helpful for me to walk into that room and not only be able to speak from a research background, but say, oh, no, you know, we also build tools, and I have experience with enterprise rollout and testing, and, you know, like, so I, you know, that experience is really valuable to having authenticity in front of a business audience. Yeah. So I didn't realise when we started this, but it's actually been quite a good environment to do this kind of thing. And I would say that having, like, for any large or ambitious research program, like most things, you need, I guess, some fundamental things. One is some stability in your own job, which is, like, really hard to come by often. Like, to think, will I be here or have some support, a continuing position or whatever for 5 years to see this through? That's like a real privilege to be able to say, this is, I'm going to spend the next 5 years of my life or whatever, knowing I might not show very much for it for the first 2 or 3 years, but I want you to trust that eventually this will become really important. And I have to say, like, a lot of what this is was things where I sort of had to put to one side some of the local advice I got from my academic peers, who all look at this and think it's a waste of time, or did. Maybe they do or not now. Like, we actually didn't used to talk about some of this stuff because with our peers, because we knew that they would see it as like a distraction or something from traditional research activity. But we knew that above us, the faculty at the university level, they were really into this sort of thing. So having the ability to know those, like, higher influences or support was important. So having some stability, and then having some people above you with the ambition and the vision that was aligned to be able to say, yep, we're willing to, you know, this is an unusual thing, it's not for everyone, but we can see why this might be important, we're willing to back it. That's been our story. Others will have found friends with philanthropists, or, you know, there'll be engagement partners who might have a similar kind of opportunity to support. But, you know, it's definitely a consideration when it comes to, like, building ambitious things. But it's my view that, like, what's the point of an academic, like, university role if we don't, like, the whole point should be that we have the stability and the time to tackle really big things. Like, that's what we're here for, and trying to, if possible, disengage from the, you know, the grind of, you know, getting only papers out, lines on a page in a peer-reviewed process. It's important, but we need to have alternate visions of what success looks like, or what is backable. And this is risky, right? So you need also people willing to back you and understand it may not have worked. Like, we might get 3 years in and be like, you know, our measurements are not working, we can't solve the problems, no one's really interested, you know, like, but they're like, that's fine, it was worth trying. Yeah.
We have a question online.
Great.
A question on publishing findings. Elena says, quite interested in scientific communication to the masses. Any tricks on spreading knowledge or warning people without sensationalizing or fear-mongering, or people or organizations that actively work on this, keeping in mind that people's understanding of data science is very weak?
Yeah, so
It's varied.
yeah. What has happened, I guess one way of explaining or understanding that that I can share is what you'll see when we've partnered at the Observatory. And again, I'd say, like, my advice would be, start somewhere about sharing your capability by exposing certain aspects of it, but then be willing to engage with, you know, for me, like, our local journalists are actually, I know now the science journalist team at our local ABC News, our broadcaster in Australia, quite well. And they will write to me about stuff happening and ask my opinion. And it's not, I know it's not going to go into necessarily a news article, they're interested or they've got something coming, but that's because I've spent time with them on phone calls or Zoom chats or whatever, trying to educate them as much as I can about the strengths and weaknesses of, you know, what we can do and so on. So my tips for that kind of stuff is my strategy, I guess, if it's worked, has been to try and become as available as possible 24/7. Like, so if someone from a reputable news organisation contacts us or me through email or whatever, I will try to say, yeah, happy to talk, you know, is now good, like, or because their life cycle is really short. So like when, the example of that was when Ukraine were invaded, two things happened. One, our server, which had the old IP Observatory site, crashed and we needed to upgrade it. I was actually at my kids' school fair on like a coffee thing, and I was getting messages from our like engineer saying we need to do something. I was like, sorry, a war's broken out. I sort of need to go. I'm sorry, I can't continue my volunteering. And they were like, okay, fair enough. Off you go. And then I had a cascade of questions coming in, and I remember like by 1 a.m. that night, I'd set up, I was having a conversation with the Reuters cyber team, explaining, because they had all these questions about like internet going offline, about, you know, what the likely, was it whether the Russians were targeting infrastructure specifically. And I was, you know, rapidly doing all these analysis of the data that was coming in from the front lines and so on. And, you know, I was like, well, you know, I'm in Australia, like, and they are like, they're often like, oh, you know, could you talk now? And I'm like, sure. And like, it's, you know, whatever, midnight. And I'm like, you know, so being as available as possible has been a sort of a strategy, I guess, a tip. And that doesn't always work very well with life, but it has sort of cultivated a sense that you're always available to like help, and also then being willing to spend the time to explain. So I must have spent probably 45 minutes talking to those guys. And I think we might have ended up being mentioned in like, you know, they took one line of quote or something in an article the next day, but I was not interested in that at all. It's the fact that I'd been able to kind of explain to them so that then every time we subsequently were putting out information, whether it was about that, I knew those guys were going to read it like well, and I didn't, and we built some sort of trust. And even now, like when I sent to them about the new website, they were like, you know, it was like friends. They're like, you know, oh, it's great to see Simon. You know, like we'll take a look. So over 5 years of like just being available, spending the time, and trying to make things digestible. And what we've worked quite hard on in our, like when I did put out a tweet, is to do some sort of graphic or visualization which is as clean and clear as possible, like really focusing on what is this image or figure communicating? What's the one message it's trying to communicate? And annotating it, and, you know, this is showing, like all those sort of things to make it as accessible as possible to as wide an audience as possible. We've come to realize that, yeah, our data can easily overwhelm even data sciencey type people. And so you need to be quite good at working up to the insights layer, where you're producing some very high level one graphic or something that really clearly shows the thing that you know about in as accessible a way as possible. If you've got that capability, great. If you need to call in that capability or get someone to read it or give advice, then that's probably what I would suggest. It's a fair concern.
Yeah. Was that? Did you want to follow up on that? That's great. Thanks. I mean, that is, I don't know how feasible that kind of entrepreneurial sort of initiative is in psychology settings in departments. Because yeah, really, like publications are everything.
Yep.
And I suppose the exception would be if you were pulling in grant money. with something like this?
Yeah, so certainly that's one angle that has maybe helped the story and why we've continued funding. So we've I guess having the UN as a consumer of our data and a kind of a engagement has opened a lot of, I think, support and doors, because it's very hard for Monash, my institution, to be like, oh, what good is it doing? And say, well, we provide data to the UN every day. They're like, okay, fair enough. Sounds important. The reality is that brings in $0 to actually the IP Observatory. It helps. We've actually, they're a customer of Casper Data House, our Spartan startup, but at a low cost price, because it's like such a valuable partnership for impact that, so that's, I'm visiting them on Friday. I think we have a real mutual respect. We've been through kind of a lot together in terms of our data raising the profile of internet measurement in the UN and human rights, changing the view of the internet as a human rights issue, and with the increasing use of the internet space as a tactic for authoritarian regimes and human rights violations, they've needed more and more kind of a trusted arm's length source to validate, things. So that's all kind of happened in the background. We did receive funding from Defence Science in Australia. And so, that was maybe a bit of a proof of principle. Like, they provided a fairly large grant to do research around our technology and capability in the Southeast Asia and South Pacific. Because the challenge there is you've got lots of different small nations who are very much susceptible to internet disruptions during elections. And not to mention natural disasters and so on. And so that's a security strategic risk that they're concerned with. And so we were willing on that partnership to kind of proceed. So I think you're right. Like, if there's the potential that, seed funding can attract, larger investment because of the application of it, then that's usually a way to win the story. But I would say, as with most universities, these things are usually done, like, the thing is usually more personal, and knowing someone outside, beyond the department at that higher levels of concern has been really important to us. I don't know how that sort of thing comes about, but there has been some serendipitous moments for the observatory's life, like when the COVID-19 pandemic hit in Australia and Melbourne in particular. The provost of our university set up this cross-university collaborative team of professors, and this time I was quite junior, but I got invited, and he wanted, every month we had these meetings with like this amazing collection of people who were like, it was called the Melbourne Project, which was like, his vision was to bring all of these different capabilities to share what they were seeing in their domain about the impact of the pandemic on whatever they were looking at in data or communities or whatever. And I would get asked to do like a pop-up and like talk about, it was like the internet weather for Australia while, in the pandemic. And I saw that this was like an extraordinary opportunity to sort of, hi everyone, I run the IP Observatory, we measure the, internet at global scale, and this is what we're seeing this week. And then I'd sit down again. And that moment probably elevated the profile of the observatory at the university layer, and meant that subsequent conversations, it was not trying to explain it who we were, but actually like, oh, I know about you. And that kind of can change it. So I guess with most large institutions, like, setting up big platforms requires some friends and taking opportunities and maybe, serendipity to get some opportunities to like make those influential moments. We've certainly benefited from support beyond our local department, mostly at the faculty tier for us, but with friends also at the university tier. Because in general, they're usually, and most universities, I think, more interested in the big, engagement impact story, and are willing to let departments figure out the sort of local promotion, whatever, researchy type things. But there's some oxygen opens up at that higher levels for these more ambitious projects, but it's about finding that pathway to them. Yeah.
You don't feel like being a little bit behind on the publications track has impacted you that much?
In the end, no. The lived experience was, I felt pretty much like I held my head up thinking what I'd worked on was important and eventually would be seen probably as important. At SFI, Dan Rockmore, when he sort of saw out our group of, scholars over a summer, some of there was like, stay safe and do good work. And I was like, ultimately, like, each of us has to sort of think about what are we trying to achieve with our academic life. And I thought I had this sort of sense that this was important. And it originally took months and months of dedicated coding to like get stuff happening for the observatory. Like a lot of work, and diverted a lot of attention from traditional stuff, and we haven't been nearly as active. And yeah, I mean, I had to sort of, in some senses, put aside expectations of progress, career-wise, just thinking like, that's okay. I think this is still important, and for whatever reason, at the moment, it's not being seen by that, but eventually, I hope it will be. And so that was not easy. And there were times when I got the feeling between a local leadership, which was pulling in one direction, and then faculty or university leadership was pulling in another. And I felt very much like I've actually said to them, I can't live like this for much longer. Like, I'm being pulled in two different directions. You need to talk and work out what you want me to work on. And in the end, it was the faculty university that won. So I'm actually seconded out of my department to the faculty at the moment for 5 years to sort of do all of this stuff. So again, a very unusual setting, but I guess the value that they see for all of this, work in general is what probably carried the day. But I don't want to, gloss over it. There was a lot of turmoil, and like, I'm more relaxed now than I definitely would have been like 3 years ago, when I was really in the thick of feeling like, I was just sinking time into this because I liked it and I thought it was important, these sorts of things. But just feeling all the time like I knew there was people who were not going to be happy with what I was doing. Yeah. And just
Doing it anyway.
doing it anyway. Yeah. Basically.
Nice.
Yeah.
Thanks so much. Other questions?
Which is why I wouldn't really suggest it for junior people. Yeah. I mean, on the other hand, I do, because I like maybe a bit of non-conformity, but you need mentors or champions who have some street cred to be able to say, no, this is important. And I think we've benefited from a few people in the university who've caught the vision and understood what we were trying to do and said, okay, no, we should continue doing that.
And I agree with you totally about the stability issues. Without it, like, you can't think long term at all.
Yeah. And again, I mean, that's like, it's a real privileged position to be able to say, am I willing to kind of do this for 3 or 4 years and see how it goes, and sort of think in that timescale for a project. And like, what you can do is pretty cool, but it's it's very countercultural for our academic colleagues. Yeah.
Okay. I think we can end the online events here. Thank you so much, Aleda, for staying on all the way to the end. Our final participant remaining. Thanks everybody, and thank you, Simon, for this session. And we'll end here for today. I hope you will join us on Thursday for Joshua Klinging's session on integrating computational science with critical theory, which promises to be super fascinating. Have a good day.